Okay, so hi everyone, welcome to Vedantu NEET English. I'm 𝐂𝐡𝐞𝐤 𝐎𝐥𝐚𝐲, your chemistry master teacher. So yes everyone in the chat box, am I audible? Am I visible? Everybody in the chat box, beta, am I audible? Am I visible to everyone here? If so, then write yes and green hearts in the chat box. And very good morning to all of you. And beta, in today's lecture, it's going to be a fun session. Why? Because this chapter is actually very easy. Purification, qualitative and quantitative analysis is a very simple chapter, right? So firstly, we will talk about different methods of purification. After that, we will talk. Thank you. She's also written Chintu ma'am with so many green hearts, right? Just the way I want. Okay, next is Akhtar, Madhumati, thank you so much, beta. Acha, Indira, thank you so much, everyone. Thank you so much for your appreciation. Thank you so much for that. Okay, beta, why I am not able to see your chats here? Beta, are you able to see this clearly or not? I think no, hai na? You're not able to see that clearly. Chalo, no issues. Now, is this visible to everybody? Is this visible to everybody? Beta, be active on the chats, hai na? Don't make this class very boring. If I am not audible, then let me know in the chat box. Don't make this class so boring that I might, like by teaching only, I might fell asleep that okay, oh, so like very boring, very boring. Don't make it so boring, okay? Hey Bhagwan. Beta, you guys are not sleeping pills. है ना? Neither am I a sleeping pill. Okay, that you guys sleep. Beta, this is not how I am going to teach. And trust me on that. I'll stop then. I'll seriously stop. Be active in the chat box. Okay? Ma'am, this is a practical chemistry concept. No. Practical chemistry is a different thing. In practical chemistry, you will have little bit of organic chemistry. You will have little bit of salt analysis and then little bit of inorganic and some portion of physical chemistry as well, right? But this is exactly not practical chemistry. This is a different chapter in your book, right? That is purification, qualitative and quantitative analysis, right? Okay. So guys, be active in the chat box. That is what I want from you guys, right? If you are not active, then you are going to ruin this particular lecture, right? Very strictly, I am saying that, right? Because no teacher is happy when the students are really, not active in the class. That makes the teacher even, very, I would say it distracts a teacher a lot. That why these kids are they not able to understand, because you are not there in front of me. And you are not there in front of me sitting in a class so that I can see your expressions. All I can see is your charts, whether you're able to understand or not. If you're not active in those charts, then probably I will think that okay, maybe I don't know whether they are able to understand or not. That is the only way of communication that I have from you, right? So let's be active on that, rather than just listening, be active. Okay, chalo. Now let us start the session. Now beta, this is a very simple session, right? Okay, I have already concluded so many things from here, right? And then we will do the PYQs also. You'll find it very simple, right? So now the first part is purification of organic compound. So what happens in lab now? When you are in the lab, your lab teacher, right, your chemistry teacher is going to give you that organic. They will say, this is your organic compound, purify this compound. Now, how do you purify? For example, in some reactant, in some reaction, you have 2 to 3 mixtures of product that is formed. Now, in that also you need to purify things, right? That is why we have purification of organic compound in our syllabus, right? So one by one, we will see different methods to purify things, right? So first and very simple. So once an organic compound is extracted from natural source or synthesized in the laboratory, for example, it is extracted from a natural source, maybe leaf, plant, anything, right? Or synthesized in a lab, right? it is essential to purify it. There may be other impurities present in it. There may be other compounds present in it in a very excess manner, right? Various methods used for purification of organic compounds are based on the nature of the compound and the impurity present in it, right? So it's not like you can apply all the methods to all the compounds, right? There are different methods. We will see which method is applied to which kind of mixtures, right? So the first method, wait, yeah, this is the table. So methods are sublimation, crystallization, distillation, differential extraction, and chromatography. Out of this, the most important is distillation, market DM, very important. Then chromatography, DMM, very important, right? So these two are very important purification methods in your syllabus, right? Otherwise, sublimation, crystallization, differential extraction, they are so very simple. But distillation and chromatography had other types also. So in that way, you have to, especially chromatography, a question can be asked easily from this chromatography, right? So let us understand one by one. First is sublimation. Now tell me, everybody in the chat box, you used to learn this when you were a kid, right? In 9th and 10th class, what is sublimation? What is melting? When you convert solid to liquid. From liquid to gas, it is vaporization. But if you want to convert solid directly to gas, there is no liquid state in between. You want to convert solid directly to gas. For example, you have camphor in your house, right? Camphor, you understand camphor, right? So camphor, very famous for its very beautiful fragrance, right? We also use this in our puja houses, and we also use this in mandirs, right? So this camphor that we have, what we do when there is some heat, we supply some heat to camphor, it is directly converted into the gaseous state, from solid to gaseous state. That is first example. Second is naphthalene balls in your house. Now I told you yesterday itself, naphthalene, right? Naphthalene balls are basically you want to save your clothes from mosquitoes, right? For example, there is change of season and you want to keep your clothes somewhere. Now you don't want that mosquitoes might attack it. So to save your clothes from that, you have naphthalene balls in your house, right? Ask your parents, you must have naphthalene balls in your house, right? That is also, for example, in 3 months, you haven't seen those clothes, right? You have just added naphthalene balls somewhere in that particular setting, right? Now after that, what will happen? That balls will just evaporate somewhere, right? So basically what is happening, solid is directly getting converted to vapors. And also in concerts and marriages and weddings, what you have seen, that there is some kind of a snowy thing, right? Artificial snowy thing, right? So what is that white snowy thing? That is nothing but that is dry ice, right? Okay, so that is dry ice, that is your solid carbon dioxide is converted into vapors form. So that is also sublimation. So very different methods of sublimations, right? So now with this sublimation, how can we differentiate between two things? So it is very simple, beta, just give me a minute. So it is very simple. For example, in a lab, you have two compounds. One compound is sublimable, other compound is not sublimable. Okay, in the lab, what it will be? One compound will be sublimable, other compound will not be sublimable. For example, I have camphor with some phenol, right? I know camphor is sublimable, but phenol is not sublimable. So now, if one compound is sublimable, when I heat it, that compound will be converted to gas and it will vaporize, right? And I'll be left with just another compound that is non-sublimable. Understood that thing, beta? For example, you have a beaker. This is my desi beaker, right? In a beaker, I have two compounds, right? Two compounds. Now I know one is sublimable, other is non-sublimable. When I heat it, when I supply heat to it, so that compound which is sublimable, that will get directly converted to gases, but the other compound which is not sublimable, that will stay as it is in the beaker. That is called when we purify things with the help of sublimation. Right? Some substances change solid to vapor state without going through liquid state, that is called sublimation, is used to separate sublimable compounds from non-sublimable impurities. Right? Examples of sublimable compounds are ammonium chloride, very, very important example. Then you have dry ice, as I told you, right? That is used in weddings and concerts, right? That is used there. Then you have iodine, a very good sublimable substance. Naphthalene balls, camphor, all these are very good sublimable substances, right? Now, beta, are you able to see this? Are you able to see this? Now, basically, what is happening here? You have where it is, ammonium chloride. Now, I told you that ammonium chloride is sublimable, right? Now, you have a cotton plug over here. Now, what will happen? You are heating it. This is the China dish, right? It's like a plate. Right? China dish is like a plate, right? It is made up with a specific material because, for example, you are heating your simple plate or simple glass, right? What it will do? For example, I start to heat this particular glass and it will break, right? So that is why the substance, the apparatus of the chemistry lab are made from different substances, right? Not normal substances. That is why when we are providing heat directly, it will stay as it is. There will be no effect on that. So you have added ammonium chloride to it, right? So there is opposite, there is inverted funnel you have put here and there is cotton ball here. So now inverted funnel, right? Inverted, what is funnel? Funnel is like this, okay? Funnel is like this and a thin pipe over here, right? This is the funnel. Now, when you invert it, it looks like this. Now, so what will happen? Ammonium chloride is going to vaporize here. And the other compound, which is non-sublimable, will stay here, right? So that is how you differentiate between non-sublimable and sublimable substances, right? So that was a very simple example, very simple method. Second method is crystallization method. Again, this is also very simple method. Crystallization methods. So have you ever made crystals in lab? I think, yeah, no. In 11, 12, there is no crystallization method, right? So in crystallization, there are different processes of making crystals. Right? Very beautiful crystals you can make in lab, literally very beautiful crystals. Now with those crystals, some crystals take 1-2 days, some crystals might take 1 week, right? So this happens, right? So in crystallization, what they are saying that one compound will be that compound which can easily crystallize. Other compound will be that which is not easily crystallizable, right? So we will differentiate these two compounds on the basis of crystallization. For example, I have impurities, right? I have a mixture, right? And now I have chosen a method of crystallization. Just give me a minute. I have chosen a method of crystallization. So what I will do, I will start, there are so many methods of different crystallization depending upon the kind of compound that you have, right? So after crystallization, what will happen? The substance which is able to crystallize will form crystals and the impurities present in it will not form any crystal. So they will be separated out with the help of crystallization. Understood that? Now, it is based on the difference of solubilities of the compound and the impurities in the suitable solvent, right? You have a suitable solvent, right? You have any solvent, but depending on the type of organic compound that you have, right? So depending on the different solubility, more soluble it is, right? Less crystals it will form. So basically it will be, this is your solvent, impure compound dissolved in the solvent at high temperature. Right? Now what you will do, you will start to, solution is concentrated to get nearly saturated solution, right? For example, you are heating something. Now we all know that when we are heating water or anything, for example, you have, let us take an example, you have a water and you have added sugar to it, right? And you are heating it, right? So you will get a very thick sugary paste, right? That is used in gulab jamuns and jalebis and all these things, that paste is used, right? So what is that? we are actually making a saturated solution here. We are evaporating the water by heating, and we are making a more concentrated solution here, right? The same thing we are doing here. And after that, when you have made a saturated solution, that saturated solution to that extent that no more solute can be dissolved in that, right? After that, what you will do after doing this process, you will just leave that in a cool place, maybe for 1 day, sometimes for 2 days, sometimes for 1 week, depending upon the type of crystals that you are forming, right? So on a cooling this solution, pure compounds crystallizes out, right? This we used to do in labs, that we used to leave that particular solution. We used to make this particular solution by different processes, and after that we used to leave that in the lab, and we used to write our names and roll numbers in that crystal, and there was so much fight among students that this is my crystal, this is my crystal. Oh god, those days, right? So beautiful crystals. See, the more saturated the solution is, the more accurately you have done the experiment, the more beautiful crystals will be formed, right? If you have not done the process accurately, you have not applied the instructions that are provided to you in the lab manual, then your crystals will not be good, right? So here you will have your crystals are removed by filtration, and other impurities will not be crystallized out, right? Okay, so now the filtrate, now they are saying the filtrate contains impurities and small quantity of the compound. Now what is the filtrate? For example, okay, chalo, so I'll take this hand only. Okay, for example, in my hand, this is a china dish. Okay, in this china dish, what I have the crystals formed, and the impurities are separated out, which are not in the crystalline form. So what I will do, this is my glass, I will use a filter paper here, and I will just try to filtrate. I will use the filtration method. I know it's like a chai patti thing, you have tea. What you do, for example, you have so many, for example, you have made a juice, right? Anything you have made, right? So now what you want that fibrous part to be out of that juice. You want just liquidy part. So what you do, you just put it in the filtrate, and what you will get the watery part inside it in the beaker, and rest of the part will be in the filter paper or anything that you have used here. In the chemistry lab, we use filter paper, right? So what will happen, the rest of the part will be out in the beaker, and the important part, that is the crystals, will be there on the filter paper. So this is called the filtrate, right? So he is saying that filtrate is the impurities, the filtrates that you have taken out, right? These are the impurities. Impurities impart color to the solution, are removed by activated charcoal, and the rest of the impurities will be removed by activated charcoals. Okay, so you can write it here, activated charcoal, right? Yeah, soup. Chalo, now this is a very important from sublimation and crystallization. Very rare chances that they will ask you questions from sublimation and crystallization, right? They will not ask. Firstly, they will not ask. It's like they want to ask a really easy question, then they will ask. Otherwise, a good question can be asked from distillation, right? So now let us see what is the process of distillation. So basically, distillation process is regarding the boiling points, right? Crystallization, we have difference of solubilities, right? In distillation, you have a difference of boiling points, right? It is based on the difference in the boiling points. Now we will see that there are two people, okay, two students. One is A, one is B. A is very fast, like he wants to vaporize. For example, you have provided a little heat, and he is like, okay, I want to convert into gas, right? So that means he has a very weak bond with other molecules, right? That is why he wants to, for example, your bonding is very strong with your friend, right? So in that way, your boiling point will be very high, because to break your bond, it is very difficult. But for example, your force of attractions are very weak. In that case, you apply little temperature, and a little temperature given to it, and it will be converted into gas. That means boiling point is very low, right? So all the compounds have different boiling points. right? So depending upon the difference of the boiling point, we apply different distillation techniques, right? Different distillation techniques are applied here. So distillation is the process of separating the components from a liquid by using selective boiling and condensation, right? Acha, what is condensation, everybody? What is condensation? Condensation is, see, these are opposite to each other. Boiling is from liquid to gaseous state. Condensation is from gaseous to liquid state. Okay, so how we are going to do these two processes, we will see that with the help of diagrams. So now you have four types of distillations. First is simple distillation, second is fractional, then distillation under reduced pressure, then steam distillation. Very, very important. All four types are very important, right? Okay, very good beta. Separation of volatile from non-volatile, or from volatile from less volatile, right? Okay, chalo. So first is simple distillation. In simple distillation, first is how much difference in boiling point you should have, right? For example, this is your Tanuja and this is Madhumati, है ना? This is Tanuja and this is Madhumati, ठीक है? Madhumati. Now Tanuja is like, ma'am, I want to boil at a very low temperature. For example, Tanuja is very, very fast, है ना? ऐसे भाग भी. She is running. Madhumati is like, okay, just relax. I want to relax. Okay, I am not that you will give me heat and I will just go crazy, है ना? But Tanuja is like, I want to run, है ना? So that means the boiling point. Achha, if you talk about the boiling point, I know that Tanuja wants to run at a very fast pace. She wants to run at a very fast pace. So what she will do? That means I'll give her a little pump. Hey Tanuja, you can do this, you can do that, you can do that. So Tanuja will be like, okay, really ma'am, I can do that. Okay ma'am, then I will run. That means a very little push is needed. That means a very little boiling point is needed for her to run. Same is with the solutions also, right? So for example, I am taking now, this is A and this is your B. A has more boiling point. Now you tell me which will vaporize first. Bacha, everybody in the chat box, which will vaporize first? If you have A has more boiling point. This is, I am telling you the boiling point. One who has more boiling point is like, I am very sigma male, sigma female, है ना? So you just give me little push, I will not run like that, है ना? So that means too much tantrums it has. A has too much tantrums. That means boiling point is really high. That means the rate of vaporization will be very slow. That means the rate of vaporization will be very slow, right? Because it needs low temperature to get vaporized and it needs high temperature to get vaporized, right? है ना? Tanuja A, हाँ, चलो. So now that is clear. Now second thing what will happen? Now let us see second thing what will happen. Now in simple distillation, when for example two people, there is Ramu and Shamu, है ना? Shamu is very slow. Okay, Ramu is very fast. So in that case, when you have a very big difference between Ramu and Shamu, in that case you apply simple distillation, right? No complexity is there. You apply simple distillation. One is very slow running like this, other is very fast running like this. Okay, so that means the difference should be of 80 degree. Okay, I am writing it here. The difference of, where should I write it? The difference of 80 degrees Celsius. If they have 80 degrees Celsius or above difference, for example, I have 100 degrees Celsius and 200 degrees Celsius. These are the boiling point of the two mixtures that I have. So when I have two mixtures which have a boiling point of differences of around 80 degrees Celsius or more, then I can say I can apply simple distillation here, because one is very fast, one is very slow, right? So now let us see how to apply this distillation. Beta, are you able to see this, everybody? Are you able to see this? Is this visible to all of you? Is this visible to all of you? Now let us see. This beta RB flask, we will see RB flask everywhere. This is a round bottom flask. That means the bottom here is round, okay? The bottom here is round. This is called round bottom flask, right? Now what we do, usually for distillation, we use round bottom flask, right? And here we have heat, we are providing it heat. Okay? So you have mixtures. For example, you have A and B here. I am writing A and B here. A plus B. You have A plus B here. है ना? You have A plus B. अच्छा, you're not able to see that? Chalo, don't worry. I am drawing it in front of you. Okay? So you have A and B here, and this is your stand, and here you are providing the heat. Okay, this is your stand, and there you are providing the heat. And now is this visible, right? And this is connected to this, so that for to balance it, right? It is connected to this. Now this is your round bottom flask. This is round bottom flask. Firstly, you need to understand the apparatus, right? Round bottom flask. Okay. In the round bottom flask, this is a very, very thin line. Okay, very, very thin pipe, right? Very, very thin pipe, cylindrical pipe type of thing, right? So now, beta, what you will do, you have A plus B in there. Okay, you have A plus B here. So I am saying that what I told you, that A has more boiling point. Na? A has more boiling point, right? And A has more boiling point means A will vaporize later and B will vaporize fast. है ना? B will vaporize fast. B is going to vaporize fast. Is going to run. So when I am providing a temperature, let us take an example that A is having a boiling point of 200 degrees Celsius, right? And B is having a boiling point of 100 degrees Celsius, right? Now what we are doing, we are providing heat, है ना? We are increasing the temperature. Here we also have a thermometer here. We also have thermometer here, thermometer to measure the temperature. Now when we know that we are at 100 degrees Celsius, B will start to boil and get converted to gases, right? B will start to boil and get converted to gases. B is now boiling, right? And it is getting converted to gases. Now what will happen? I will have this condenser. What is the condenser? What is the work of the condenser? Condensation is from gas to liquid, right? So what I will do, this B component is getting converted into vapor and it is going through this condenser. And in this condenser, what we are doing, this is at that temperature so that we can condense this gas into liquid again. So now this B that is converted into gas because of the boiling is now again converted back into liquid with the help of this condenser. Okay, this is your condenser. This is your condenser, right? This is again converted back into gas, liquid, right? And hence, in this beaker, you will collect the B, है ना? You will collect B in the liquid state, and here you will have your A, that is your solid, that is your different. Now, you have two mixtures. Here you will have your A, which has higher boiling point. Still, we have not achieved 200 degrees Celsius because the difference is so large. By the time all of the B is converted into gases and then condensed, A boiling point we have not achieved yet, right? There is a difference of around 80 degrees Celsius, which is not easy to achieve in seconds, right? And within that time, this B will vaporize and get condensed, and we will have a different beakers where we'll have A and B. But tell me, is that clear to everybody? Is that clear to everybody what we have done? Is that clear to everybody? Tell me, beta, I am drawing this. Okay, this is all, there are so many stands that we need here, है ना, because we have so many things here, है ना. We have this condenser, it will be with the help of a stand. Here this beaker will be with the help of a stand. This round bottom flask also with the help of a stand, right? Then you have, these all are stands only. This is your round bottom flask where you have mixture. This is your condenser, from which the one which has less boiling point, it will be vaporized and getting converted into and then after condensation it will get converted to liquid and they will separate out. Okay, is there any problem in this? Thank you Madhumati, thank you bacha, thank you. Okay, that is clear, right? Okay, that is clear, right? है ना? Chalo. Now let us see what is there written in the theory part, because theory is very important. Firstly, we will understand things with the help of diagram, then we will read out the theory, right? What kind of question? These lines are from your NCERT only, and reading NCERT is enough for this chapter, right? So this method is used to separate volatile liquids from non-volatile impurities. Okay. Second thing is the liquid. Here they have written non-volatile, but the difference, if I saying the difference is greater than 80 degree, also then we can apply simple distillation, right? Either we can say volatile from non-volatile, or also if the difference is very large, right? Next is the liquids having sufficient difference in their boiling point. Okay, so two ways we can use this. One is volatile from non-volatile. Second is when you have a sufficient large difference, and that I am saying which should be greater than 80 degrees Celsius, right? Which should be greater than 80 degrees Celsius. Now, example, you saying example is when you want to, this is example from your NCERTs only, that chloroform and aniline are easily separated by this method. Very, very, very important. Write it down in your notebooks, right? They will ask you that how, if you want to separate chloroform and aniline, which method will be applied? The method will be simple distillation, because there is a sufficient amount of difference in the boiling point, right? Because there is sufficient amount of difference in the boiling point. Acha. Next is liquid having different boiling points vaporized at different temperature. The vapors are cooled, then liquids are formed, collected and separately. This bit of we have seen. Acha. The liquid mixture is taken in a round bottom flask and heated carefully. Hai we will take that mixture in the round bottom flask and we will heat it. Then on boiling, vapors of lower boiling point components are formed first. Which will be formed first? Which has low boiling point, which is very, very like, I want to go, I want to go, I want to run. Give me a little push and I will go. Hai give me a little push and I will go. So we just gave it a little heat and it will just vaporize. The vapors are condensed by using condenser, and the liquid is collected in a receiver. This is called the receiver. Okay, write down here, this is called the receiver, where you will collect the liquid which has low boiling point. Okay, in the receiver, beta, they can ask you directly that in simple distillation which liquid is collected at the receiver, with high boiling point, low boiling point, no selection, aisa karke, right? Then you will say with low boiling point, that thing is collected at the receiver. Next is the vapors of higher boiling point component form later, and the liquid can be collected separately, right? Firstly, we will collect the first liquid, and after that either you can collect it, right, if that is still in the boiling phase, or you can just or you will just have that other liquid in the round bottom flask. That is totally your choice. Okay, so second method of this is second kind of distillation is fractional distillation, right? Fractional distillation. So fractional distillation, the difference in the boiling point is not that large, right? So for that, when the difference in the boiling point is not very large, we will have different methods, out of which first method is fractional distillation. So in fractional distillation, firstly let us see the diagram here. Okay, firstly let us see this thing. Can you see, beta? These are your diagrams from your NCERT itself, right? This is one thing. This is the path of the round bottom flask. See, this is your round bottom flask. Now I am zooming this particular thing in. Okay, I am using this thing in. Now, when you zoom it in, what will happen? This is your round bottom flask, right? This is the upper area of round bottom flask. Now, I have two things here. If you can observe that there are so many beads here. There are so many beads here. So many beads here, right? And in this path, the path is little zigzag. है ना? The path is little zigzag. You have zigzag kind of path, right? You have zigzag kind of path. Now, why we are doing these things? Why in the path we have made some kind of things, like we have, for example, we have speed breakers in our streets, right? We have speed breakers. Why we need speed breakers? Anybody in the chat box? Why we need speed breakers? Because some people, they drive so fast. To slow them down, government has to add speed breakers on the streets, right? And sometimes the speed breakers are like, if your speed is really, like if you are driving on the wrong side, then I think there is some pin that will get connected to your tire and it will punch the tire, hai na? Something like that also is there, right? So why it is so? To slow down your speed, because we know that, yes, to break the speed. Yes, Gopika ma'am is there to break the speed. Yeah, so we just want that person to slow down, right? So similarly, you have these vapors, you have mixture, and the boiling point is not very different. They both are like, both are like very excited in life, very happy in life, right? Both will be like, I want to go, I want to run, I want to run, I want to run. There is not such a big difference here. Now what will happen? Now we have to slow them down. We will create some resistance in their path, right? And that resistance is going to be in the form of these glass beads, or in the form of different path, that is zigzag path, right? That is called the fractional distillation, when you are creating the resistance in their path, right? Now when you have created a resistance in the path, now you will see who will win. Now we will see who will win even with the resistance, right, bacha? Okay. Hi, bye, go study. Okay. So now here you have this thing. Now I am drawing this diagram for you. Let us see. This is your round bottom flask. This is your round bottom flask, right? And here what you have, and here beta what you have. This is your two mixtures. I am saying A and B. This is A and this is B. And this is B. Okay. A with the blue pen and B with the red pen. Now I know that I have some restriction in the path, and that is by fractionating column with the packing. You have packed it with some glass beads, right? And here beta, this yellow, there is one yellow portion outside it. That is the oil bath, right? That is the oil bath. Now you are heating it. So now beta, this is your stand and you are heating it. Okay, you are heating it. Now what will happen? Now everyone, what will happen? We know that one of them will win. For example, A has a boiling point of, A has more boiling point as compared to B. This is what we were taking in the last question only, na? A has more boiling point. Yeah, let us take this also here. A has more boiling point than B. We know that A will vaporize less and B will vaporize faster. The vaporization, the rate where they want to run will be faster in B, beta, hai na? Which has more boiling point. This is what I told you in the last part as well. Which has more boiling point will run at a slower speed, right? It's like I have too many tantrums. For example, there is an elder and a younger brothers, right? Elder brother has no tantrums, but younger brother is like, I don't want to eat this, I want to eat this. So many tantrums, hai na? So this is your this is your younger brother, that is A, which has so many tantrums. B has no tantrums. That is why B will vaporize fast. But now the problem is the difference is very less. For example, A is at 100 degrees Celsius and B is at 105 degrees Celsius or 110 degrees Celsius, something like that. Okay, so the difference is very less. And as soon as we will reach A, 100 degrees Celsius, within few seconds we will reach B also, right? We will start evaporating both of them. For that, what we need to do? We need to have a restriction. We need to have some kind of resistance in between. For example, this is A and this is B. Okay. So what is happening here? Let me see. Okay. Chalo. This is your A and this is your B. Both A and B are in the beaker. They are in the beaker. Now I have provided heat. Now A has which boiling point? 100 degree. So now what will happen? Now you can see this is your beaker. Okay, this is your beaker. You have A and B in this beaker. You start to heat it. You are heating it. What will happen? A, which has less boiling point, will start to vaporize. But now, because of these restrictions, what A will do? A will try very hard, but still it will run. But by the time it is in between here, B will also start vaporizing. Right? Now there will be fight between both of them, but because the path is very restricted, because of that reason, the path is very restricted, this will somehow move, this A will move somehow faster as compared to B, because of the restrictions that are provided in the round bottom flask. Okay, understood that thing, beta? What is happening here? Now A has somehow win here. So what A will do? Again, everything else is same. In the condenser, it will get liquefied, right? And hence, you will have that in the receiver, right? And then you will have that in the receiver. Tell me, beta, is that clear to everybody? What we did here, what is the difference between fractional and simple distillation? Right, beta, what is the difference? Acha. Now, let us see some of the points here, right? Let us see the theory part here, because theory is very important. This method is used when difference in boiling point of two liquid is not too much, right? Liquid difference, the difference in the boiling point is not very high. Vapors of liquid with higher boiling point condense before the vapors of liquid with lower boiling point. Wait. Vapors of liquid with higher boiling point condense before the vapor of liquid with low boiling point. Wait a minute. In this technique, vapors of liquid mixture are passed through fractionating column before the condensation. Fractionating column are available in various sizes and designs. For example, glass beads and different zigzag manner. The vapors rising up in the fractionating column become richer in more volatile component, right? A fractionating column provides many surfaces for heat exchange. Okay, now this is important. Now this thing is very important, right? This thing is very important, right? Okay, this thing is beta very, very important. Mark it here. A fractionating column provides many surfaces for heat exchange. Beta, these fractionating column, and this column, this is called fractionating column, right? This is called fractionating column, where you will have different beats, where you will have resistance in between. So what will happen? It will, for example, there are so many such big resistance. What will happen? For example, you have these glass beads over here. Because of these glass beads, the molecule that is moving here, it will firstly strike with this one, right? And then with this one, then with this one, then with this one. Because of the collisions, there will be heat exchange. Understood, beta? Now we are going into a microscopic thing here, right? So there will be collisions. Because of those collisions, there will be heat exchange here, right? So fractionating column provides many surfaces for heat exchange. Whenever, beta, in physics, we know this law that whenever we collide with something, we exchange some amount of heat there, right? So we are exchanging heat between the ascending vapors and the descending condensed liquid, right? So both of them are exchanging the heat, right? And there is one more name for that. That is theoretical plate. This they can ask you. Okay, this is very, very important. Theoretical plate, right? This is a very, very important question. Each successive condensation and vaporization unit in the fractionating column is called the theoretical plate. each successive, for example, there is one vaporization, one condensation, one vaporization, one condensation. So each successive vaporization and condensation is called the theoretical period. This is directly from your NCERT. If they want to ask you question from NCERT, which they think that students might or might not be able to know, right? Then beta, they can ask you the definition of theoretical plate, right? This is the definition of theoretical plate. This is important, right? Acha. Now they are saying the low boiling point liquid is collected in the receiver. As I told you, the liquid with low boiling point, right, which will vaporize fast, like A will vaporize fast, that will be collected in the receiver, right? Next is the remaining liquid in the distillation flask get enriched in the high boiling point content. That means in the flask, what you will have a high boiling point liquid, and over here you will have low boiling point liquid, that is your B. Because we know B will run here, and hence here you will have your B which has low boiling. No, here you have A which has low boiling point. Kya? Which has low boiling point? B has low boiling point, na? So here we have written opposite. If we are writing B has low boiling point, it should be 100 degree, and here it should be 1010 degree, right? Okay, yes. Everybody in the chat box, beta, is that clear to everybody? Right? This erase this line. This is not a correct line. Okay. Okay. Chalo. Now let us move to the next one. That is distillation under reduced pressure. Now, firstly, tell me, before this, tell me one thing, that, yes. Now, firstly, tell me one thing, what exactly is boiling point? To understand next to distillation, you have to know the definition of boiling point. You have to understand what is boiling point. Tell me what is boiling point. We say the boiling point of water is 100 degrees Celsius. What do we mean by that? What do you mean by when you are saying that this is the boiling point? We mean that, for example, this is a vapor pressure of that compound, right? And this is the atmospheric pressure. When the vapor pressure is equal to the atmospheric pressure, that temperature is called the boiling point, right? What will happen? This is your atmospheric pressure and this is your this is your vapor pressure of water, right? So you're increasing the temperature 60 degrees, 70 degree, 80 degree. You're increasing the temperature, and we know that when we are increasing the temperature, what is happening? When we are increasing the temperature, liquid is getting converted to vapor state. For example, you have this thing, you have a beaker, and in this beaker, what you have, you have some liquid, right? Okay. So you are providing heat over here. So when you are providing heat, you know that you are actually converting that into vapors. So earlier, for example, the vapor pressure was this. And this is your atmospheric pressure. So when you are providing heat, at one point, this vapors, as liquid is getting converted to vapors, the vapors will be so much that it will become equal to the atmospheric pressure. When this becomes equal to the atmospheric pressure, then we say that here we have achieved the boiling point. Is that clear to everybody? Beta? Is that clear to everybody? Yes, I will hydrate myself. Beta, is that which empirical? Very good. Satvik, very good. Beta, notes will be provided to you on Vedantu NEET English. Okay, that is our Telegram channel. Their notes will be provided to you. Now, basically, this is your atmospheric pressure, right? And this is your vapor pressure. When they will become equal to each other, then we will say we have reached the boiling point, right? So now let us understand the distillation under reduced pressure. In reduced pressure, what you do, right? In reduced pressure, what you do? You reduce the pressure of the atmosphere. Understood? You reduce, this is your atmospheric pressure. Okay? This is the vapor pressure of boiling, vapor pressure of that compound. Now what you will do? You want to equate these two equal, and only then you will reach the boiling point. But here the boiling point will be very high in this case. So this method is applied when the boiling point of the liquid is very high. In that case, what we do? We reduce the atmospheric pressure so that the boiling point becomes less, so that we have to provide less temperature here, right? So that we have to provide less temperature here. We are decreasing the boiling point by reducing the pressure, that is atmospheric pressure, right? We will create a situation that we can't reduce the pressure of this atmosphere, but we can reduce the pressure of that environment where this beaker has been kept, right? So what we will do here, everybody in the chat box, what we will do here, everybody. So this is your diagram, right? Here you have, this is your round bottom flask, right? This is very important, and this is just not a normal round bottom flask. What we have here, this is your condenser. Now see this very carefully, right? This is your condenser, and to this condenser you have one thing, right? To this condenser you have attachment of one thing, that is your, what is that? That is your vacuum. That is your vacuum pump. Vacuum pump. Vacuum pump which reduces the pressure, which reduces the pressure. So we will create an environment for this liquid. For example, I have a liquid here. I have a liquid here, A and B. I have a liquid here, A and B. So what I will do? I will provide it heat. When I am providing it heat, what will happen? When I am providing it heat, firstly, so let me draw the diagram for you. This is the stand, right? And this is also one more stand. This is your receiver, where we are receiving everything. We are receiving the distilled liquid, right? We are receiving the distilled liquid. So now let us see. I hope this is now visible to you, right? This is now visible to you, everybody. This is now visible. Now what we will do? This is A. A will be very happy in his life. A is like, give me heat, I will evaporate. But we are like, you demand so much of heat, right? You demand so much of heat. So what we will do? This vacuum that we have attached over here, this will create that kind of pressure over here in this receiver, in this condenser, in this round bottom flask. The pressure will be low because we have reduced the atmospheric pressure here. That is why to achieve the boiling point, it will become very easy for this liquid, right? This is what we are doing here, right? Okay, we are reducing the boiling points here. Now let us see the theory part here. This method to purify liquid having very high boiling points, we want to reduce their boiling points, right? And those which decompose at or below their boiling points. There are two liquids that we have. One is having very high boiling point. One is having very low boiling point. One is having those which decompose at or below their boiling point, right? For example, they have not achieved, there are some compounds which will not achieve their boiling point. Before achieving the boiling point only, they will break. That means we don't want to break that mixture. For example, you have a compound AB. You have a compound AB, right? Its boiling point is very high. Now, when you are providing, for example, its boiling point is 1000 degrees Celsius. Now, before not even 1000, let's say 500 degrees Celsius. Okay, so its boiling point is very high. Now, beta, what will happen? We have not achieved this high temperature, but before that only, this will decompose into A and B. Now, we don't want A and B separately. We want A and B together. We want a compound. Then what we will do? We will reduce the boiling point here, right? We will reduce. But this they can ask you when this method is applied. So this is important. When this method is applied, when the boiling point is very high and the compound decomposes before achieving its boiling point. That is very, very important. Next is liquids are made to boil at temperature lower than their normal boiling point. This I told you na, we have to decrease their boiling point. We have to lower their boiling point by decreasing the atmospheric pressure. Beta, you can understand this by a very simple situation. है ना? For example, you want to crack some exam. है ना? NEET exam you want to crack. There are two methods. Either you do so much hard work that you crack that exam, or what happened in NEET 2024. For some students, they just lowered the rank itself. है ना? They just lowered the rank itself. No, they actually increased the marks. Now, for example, something happened and the cutoff decreases. For example, this is your cutoff, है ना? This is your NEET cutoff, right? This is your NEET cutoff, and this is you, right? You have two things. Either so you can reach this cutoff, or you can lower the cutoff to reach here, है ना? Your target is to achieve this exam, to clear this exam. Either you can lower down the cutoff, or you can jump to that level of that cutoff, right? There are two cases only. So here what we are doing, we are lowering the cutoff. Okay? We are lowering the atmosphere here, right? The pressure is reduced with the help of water pump or vacuum pump. Very, very important. The pressure is reduced with the help of water pump or the vacuum pump, right? Vacuum pump, have you seen in 3 Idiots? And Amir Khan used that vacuum pump with another level only. Another level he took engineering to. Acha. Now, last one is beta steam distillation. Again, very, very important. Beta distillation processes are very important, right? Now, let us talk about steam distillation, right? Steam distillation, let us see what is steam distillation. Very simple. So have you, we know two things now. We have orthophenol and para-nitrophenol. The question this is asked, right? So in steam distillation, what I am doing, this is same. This is what, for example, you are going to give an exam. है ना? Now, you are not well prepared, but your friend is well prepared. So you're doing cheating. You're doing cheating. You're doing cheating. So what is that? That is steam distillation. Okay? That is steam distillation. This is your atmospheric pressure. You can't lower the atmospheric pressure in not fractional. In reduced pressure distillation, you have reduced the pressure. Here you can't reduce the atmospheric pressure. That is same. But what you can do is you can have a friend along with you who will help you in achieving this target. For example, I am your that friend. You want to crack NEET, right? I told you there are two methods. Either to decrease the cutoff. That we cannot do. है ना? We don't have that high approach, right? We cannot do that, right? What we can do, you can have your friend, that is your Diksha ma'am, along with you, right? Who will help you in achieving that target, right? So similarly in steam distillation, you will have your friend along with you, right? Understand that thing? You will have your friend along with you, right? Now let us see. This is basically, this happens for ortho and para-nitrophenol. Firstly, let us see the diagram, because when you know the diagram, then to understand theory, it is easy. And firstly, let us know the diagram, then we will understand the theory part here, right? So this is, bacha, your round bottom flask. This is round bottom flask, right? This is where you will have condensed water vapors, right? They are moving here, and this is your one more vapors. Okay, one more vapor. This is you, this is your teacher. This is you, this is Diksha ma'am. You, Diksha ma'am. Okay, so this is Diksha ma'am, right? So we both, है ना, together will crack the NEET. This is your condenser, and here you have, this is your receiver. Okay, there are so many things, important lines over here. So many important lines over here. So firstly, for example, this is your A. Now what you will do? You want to take out the impurities from here. What you will do? You will obviously provide it heat, है ना? So for that, let us make stand and all, ठीक है? And this is your heating. This is providing you the heat, है ना? You are providing the heat over here, right? You are providing the heat over here. This is your stand, है ना? This is your also your stand. Now, this is also your stand. So much drawing I have to do today. I love drawing, but I love drawing organic compounds, not this drawing. Chalo. Now, are you able to see this? Are you able to see this, beta? I think now it is clearly visible to you, right? So we have this compound A, right? It is basically you will have two compounds. Okay, you will have two compounds. One will be more steam volatile. Steam volatile means what will happen? You will have steam along with this. है ना? Here you will have another B. What will happen? Firstly, to understand one thing, we will understand how they are separated. Firstly, let us see what we are doing here. Right? Here you have vapors and here also you will have vapors. Right? And these two vapor pressures will combine and come to this place. And here you will have, then you will have this more steam volatile compound. For example, you have two things here. You have orthophenol, and you have metaphenol. Okay, this is your orthophenol. And then you have paraphenol. This is your paraphenol. Right? This is your paraphenol. I know in orthophenol there is hydrogen bonding involved. Right? There is hydrogen bonding involved. So there is intramolecular hydrogen bonding here. है ना? This is your intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Now from this I can say one thing, that because of intramolecular hydrogen bonding, it is so involved in interacting. For example, you are in your class and you are like two best friends who are so into each other that they don't care about the world. Right? So these are those best friends. They are so happy with each other that they don't care about this world. Right? They have no bonding with this world. So to break the bonding with the other molecules, it is very easy. That means it will have a very low boiling point. That means this orthophenol will have a low boiling point as compared to paraphenol because there is intermolecular. It has a bonding with other molecules. That is why it will be easily volatile. Right? So now that is why we have the statement that orthonitrophenol is steam volatile. Right? We can easily volatile it with the help of steam distillation because it has low boiling point. Right? So the one with the low boiling point, right, it will go and then there will be one more pressure that will be added here. Then it will condense. Now let us see the theory. Okay, I will again come to this one. Let us see the theory first. Right? I will again conclude this. Wait a minute. This method is used to separate substances which are steam volatile, okay, and are immiscible with water. Now, why these two things? Steam volatile, why steam volatile and why immiscible? Now see, here you have water vapors. Now, here you have water vapors, right? Wait a minute. So here you have water vapors. That means the water vapors, they are like a steam only. And these water vapors, when you are boiling water, then you have water vapors, right? What is that called? That is called steam only. So with the steam only, this thing is getting volatile. That means it is steam volatile, right? So that is why we say orthonitrophenol has such a low boiling point that it is steam volatile. Okay? Now, the pressure of those water vapors will be added to this one, right? Which is steam volatile. Right? And after that, what will happen? Because beta, what you have, see, you have two things here, very, very important. See, this is your, see, when we are saying steam volatile, what we mean by that? Steam volatile means you have water vapors, right? Some water vapors, I am the water vapor, right? And with that water vapor, right, is helping you to get volatile, right? That is called steam volatile, right? So orthonitrophenol has such a low boiling point that it becomes volatile with the steam itself, right? So now, for example, P is the pressure of this orthonitrophenol and P1 is the pressure of water vapor, right? So over here you will have two things. Over here you will have two things. One is that compound A, plus you will have pressure of water vapor. You will have water vapors as well, right? Both of these you will have. In this you will have two kind of vapors. One will be the vapor pressure, one will be the vapors of A, that is your orthonitrophenol, that compound which is steam volatile. Second is water vapors. Understood? What happened till here? What happened? You had two mixtures, orthonitrophenol and paranitrophenol, right? And we want to see which is steam volatile, which can get volatile with the help of steam only, right? We know orthonitrophenol is steam volatile, so it will form the vapors, right? And now with this condenser we will have two things. One is the water vapors, second is the orthonitrophenol, which is steam volatile. So one we have steam volatile compound, other is water vapors, right? Both in the form of vapors. Now we are condensing it. So in the condenser liquid you will have two liquids. One will be water, because when water vapor will be condensed, they will be converted into water, right? When water vapor will be condensed, they will be converted into water, and when A will be condensed, A will be converted into A liquid, that is your orthonitrophenol liquid. Now in this beaker, that means when you are receiving it, you are receiving two things here. One thing is water, one thing is liquid of A, that was steam volatile. Now, why they are saying that this should be immiscible? Why they are saying that it should be immiscible? If the steam volatile compound is miscible with water, then what will happen? We will not be able to separate water and that compound, right? For example, you have oil and water. You know that you can separate oil and water, but you cannot separate water with alcohol, you cannot separate water with Coke, you cannot separate water with what else? Soda, you cannot separate water with any juice, not possible, right? Biggest example, you cannot separate water with milk, right? And that in our homes, we don't know whether we have pure milk or we have water, that water is added in that milk, because that these are completely miscible. Right? The milk, right? This is completely miscible with the water, right? But here, this compound should not be miscible with water, so that we can have two layers here. One is the layer of water, other is the layer of that distilled liquid, which is steam volatile. You can write here, it was steam volatile liquid. Steam volatile liquid. Beta, tell me, is that clear to everybody? Is that clear to everybody what we understood here? Hana, is that clear to everybody? Hanji. Tell me if you have any problem in that, then let me know. Hai na? You should know that these are four kind of distillation. I want to take a test of you. Firstly, to tell me, is that clear or not? If that is clear, we will revise these four. Why and how they are used. Again, I want answers from you guys. I want answers from you guys. Okay? Ha. Ha. Very good. Now tell me answer to this. Why we use simple distillation? Everybody in the chat box. I am revising it. We had four distillations. Achha, firstly, let us complete all the theory part here, right? Then, steam from a steam generator is passed through heated flask containing the liquid to be distilled. Hai na? So, from a steam generator, no, this is not steam generator, where it is? Yeah. Okay. From a steam generator, we are passing the steam over here, right? We are giving the heat. Steam from a steam generator is passed to a heated flask containing the liquid to be distilled. The mixture of the steam and the volatile organic compound, I think when you understand with the help of, hai na, very good. When you understand with the help of diagram, then to understand theory, it is easy. Otherwise, if you're just taking out the NCERT and reading it yourself, it will become difficult for you, right? First, you understand with my help, and then beta, you go and read your NCERT and go and read these notes. You will be able to understand this very easily. the mixture of steam and volatile organic compound is condensed and collected. We know that here we had mixture of that steam, volatile compound and water vapor, right? That is steam, that is distilled and collected, right? Next is the liquid boils when summer, very, very, very important. The liquid boils when summer vapor pressure, what I told you, either though you can reduce the atmospheric pressure or you can, with the help of your Diksha ma'am, can crack NEET. है ना? Simple. So they are saying the liquid boils when summer vapor pressure due to organic liquid, that is P1. Here they are taking liquid as P1, and that due to water P2. Due to water. What I told you, see, I took different, I took P as organic compound and P1 as water vapor. What they took here, they took that, we will see one thing only, है ना? They are saying that you have two vapors. One is your P1, that is for your organic compound. This is for your water vapors. Then these two together, है ना? These two together will, for example, this is you, and this is your Diksha ma'am. You are very sad here. You're like, I don't know how to do organic chemistry. I'm very sad. Then Diksha ma'am is like, hey, don't worry. I am here for your rescue, right? Then you both together will crack the NEET, right? You both together will crack the NEET. Now, what is going to happen here? I am helping you in cracking it, right? So, simply here, this water vapor is helping this organic compound in cracking which thing? They want to crack the vapor pressure with the atmospheric pressure. Same thing is equal to the atmospheric pressure. That become equals to the atmospheric pressure. Beta, understood this statement? Tell me, are you able to understand this particular equation? They can ask you this. They can ask you this. What is the relation between the in steam distillation? What is the relation between the pressure the pressure of organic compound, the pressure of vapor pressures, right, and atmospheric pressure? So this becomes the relation. Okay, this is very, very important, right? Chalo. Next is P1 is lower than P, right? So we all know, we all know that P1, है ना? So this is your level of need, and this is you. Why you need my help? You will need my help only when you feel that, ma'am, I think that I am not that much good in chemistry. Only then you will need my help. Otherwise, so why would you? You're like, ma'am, I am also a hero, ma'am. Why would I need your help? Now you're like, ma'am, I need your help. And that's why you are here. That's why you are watching the recording or live session. That's why you are here, right? So that means you need help. That means your knowledge is lower than the knowledge of this NEET, right? So that's why I am helping you here, right? So here, the simple thing is P1 is lower. Why? Because this is the vapor pressure of atmosphere, and now to achieve this, you need P2. The organic compound vaporizes at lower temperature than its boiling point, है ना? The organic compound vaporizes at lower temperature than its boiling point, right? How will vaporize? Because your teacher is helping you. That is why it will vaporize at lower temperature, right? Why? Why at lower temperature? Here, beta, tell me the answer for this one. Why at lower temperature? Because we know that I am helping you here. Beta, any statement can be asked. That's why I am, elaborating every single statement here for you. Because any statement can be asked. If they ask question from purification, they will ask you theory-based question, right? Numerical-based question, we will do that in the end, right? So that means that when you have the help of P2 vapors, in that case, the P1 will not use that much of pressure, right? And hence, when the P1 pressure will not, P1 don't have to get vaporized to a large extent because P2 is helping. For example, if you read this chapter by yourself, maybe it will take you 6-7 hours, right, to understand everything completely and to make your notes. But here I am teaching you, so in 3-4 hours, I'll complete everything with notes, everything, PYQs, everything, right? So what I am doing, I am saving your time. So in the same way, this particular P2 vapors are saving the vapors of P1. That means that is getting boiled at lower temperature. And an example is beta very, very important example is aniline water mixture separating by this method, right? You are separating this method by this thing by this method, right? So beta, now we had 4 things here, है ना? Simple distillation when the boiling point difference is very large, right? Then you have fractional distillation when the difference is very less, right? Then you create restrictions here, right? Okay, I'll show you with the help of diagram. I am concluding that. Okay, I'm concluding that. So simple distillation is when the boiling point is difference is very large, right? Okay, this is not simple. This is simple. Okay, this is your simple distillation when the boiling point difference is very large. Then you have fractional distillation, in which case you have restrictions over here because you want one thing to slow down, right? That is why the boiling point difference is less here. That is why we have created a resistance here, right? That is called the fractionating column. The resistance is called the fractionating column. Then the third is reduced pressure, where what you have in the reduced pressure, you have reduced the vapor pressure of the atmosphere by vacuum pump, right? So you have used vacuum pump, but you have reduced the atmospheric pressure here to meet that target, to meet that or that boiling point. And this is used for those compounds which has very, very high, exceptionally high boiling points. Last one is your steam distillation, when one is steam volatile compound. Now your teacher is going to help you in achieving that target, right? Okay, beta, distillation is clear to everybody or not? Everybody in the chat box. Is a distillation clear to all of you? Is a distillation clear to all of you? Yes, beta, tell me. Right? Chalo. Next is differential extraction. This is very, very simple method, right? Very simple method. So what will happen here? In this, what you will have a solvent layer. I think you are not able to see it, so I'll write it myself. You will have a solvent layer. You will have a solvent layer, and this is organic compound in aqueous layer. Okay, you will just shake it. You have two layers. One is solvent layer, one is aqueous layer. Two layers, beta. They will ask you two questions from here. Just simple method it is. One is solvent layer, one is aqueous layer. Right? So what we do, we just shake it. We'll just shake it. What will happen? The organic compound will shift from aqueous layer to the solvent layer. Okay? Now, organic compound in the solvent layer, it will be mixed in the solvent layer. This is after extraction, and this aqueous layer will stay as it is. Understood, beta? Very, very simple it is, right? This method is used when an organic compound is present in the aqueous medium, right? The organic compound with a suitable solvent you will use. Organic compound is separated by shaking it with an organic solvent in which it is more soluble than water. है ना? For example, this is your aqueous, this is your solvent. So in solvent, it will be more soluble. Now you'll just shake it and you'll be like, I am more attracted toward this solvent, so I will go with the solvent, right? So differential extraction is carried out in a separating funnel. This is called the separating funnel, a very simple method. Okay, this is a very, very simple method. Okay, ji? Okay, beta. Chalo. Now, last but very important method, your fifth method, that is chromatography. Okay? Chromatography, this also have different types of chromatographies you have in your syllabus. Okay, ji? हाँ जी. Okay, beta. So we will complete chromatography within half an hour, right? After that, I will give you break, and then we will do qualitative and quantitative analysis. Okay, chalo. Now let us do chromatography here. Chromatography, chroma means color. Okay, chroma means color. Actually, initially it was adapted. Here it is written only. Chroma means color. So initially this chromatography was adapted because, for example, you have ink, right? You have ink and you want to separate all the components of that ink. What you will do? You will use chromatography. It used to show us different colors. But in today's, we have methods where we can do chromatography even if it is not showing color, right? We have different methods for that. I'll show you those methods as well, right? So this is important technique to separate mixtures into their components. Like I told you, you will separate the ink components into different parts. Purify compounds also to test the purity of the compounds. This is a very common method that is used. Have you ever done chromatography in the labs? Right? Have you ever done chromatography in the labs? That is there in 12th class, right? Have you done chromatography or not? Because this is actually interesting experiment to do, right? It's a very beautiful and interesting experiment to do. Now with chromatography, now you need to have, firstly, so you need to understand the terms here. What is stationary phase? What is mobile phase? Right? You need to understand these terms. Right? You need to understand these terms. So when we talk about the stationary phase, right? One is your stationary phase, other is your mobile phase, and the third thing is your mixture. These are the three things that are of very important when you talk about chromatography. You need to have three knowledge here. What is the stationary phase? Right? What is the mixture? Mixture will be, for example, I have taken ink. I have taken a mixture of any compound, right? I want to separate it. That is called the mixture, where you are working. And this stationary phase, right? So mixture substance applied on the stationary. This I will tell you how to, what are different types of stationary phases. Wait a minute, we will do different type of chromatographies. Then we will understand what are the different type of stationary phases and mobile phases, right? So firstly, though, you need three things. Then in chromatography, just three things are needed. Okay, three things are of utmost importance. One is stationary phase, there is mobile phase, and then there is this mixture. Okay, now there are also different names for that. Mobile phase is also called pure solvent, and this is also called eluent, right? Pronunciation may be wrong, but spelling is also something like that only, right? So mobile phase is eluent or solvent. When you see solvent is this, or you see mobile phase is this, or you see eluent is this, that means the same thing, right? That means the same thing. Now we will do different type of chromatographies to understand what exactly is this, right? So, but sir, you have basically, I know initially you will be like, ma'am, what you are saying, but you need to have patience, right? I promise you in the end, you will be able to understand everything, but you need to have patience because there are so many things that I need to tell you here, right? One by one, I will again come to this page and I again explain you, right? But you need to have patience to learn this chromatography, right? So you need, first thing is, ma'am, in chromatography, three terms are important: mixture, stationary phase, mobile phase. Three things are important, right? We will study about in all the different type of chromatographies. We will focus on these three things, right? What is the stationary phase? What is the mobile phase? And what is the mixture, right? Second is, what are the different types of chromatographies? So there are basically two types of chromatographies. One is adsorption. Second is partition. So in our syllabus, when we talk about adsorption chromatography, we will talk about column chromatography. We'll talk about thin layer chromatography. Okay. When we talk about partition, P for partition, P for paper. Okay. So in partition, you have paper chromatography, and we are going to study in detail about these three chromatographies. First is column chromatography, second is thin layer chromatography, and third is paper chromatography. And I will try my best to visualize this thing to you. Okay, I will try my best. Now see this thing. What is adsorption chromatography? Adsorbed means, for example, you have any surface, and the mixture that you are adding here is getting into the layers, right? That is adsorption, right? Okay. The method based on the fact that different compounds are absorbed on adsorbent and different degrees. First, just go to the theory part, okay? Again, we will come here, okay? Just have patience. Commonly used adsorbent are, now beta, what is this adsorbent? What is this adsorbent? Okay, ji, what is this adsorbent? Very important, write it down here. Different names, hai na? This is called adsorbent also. If you see stationary phase or adsorbent, that is the same thing. If you see mobile phase or solvent, same thing. If you see eluent, that is the same thing. So these are the different names that can be used, right? Okay. If you see, this is what is the stationary phase, same thing. If you see adsorbent, same thing, right? Adsorbent and stationary phase are the same thing here, right? So let us see this. Commonly used adsorbent are silica gel and alumina. So when we will talk about adsorption, we will talk about two things here. First is stationary and the mobile phase. Stationary phase are the adsorbent in case of adsorption chromatography. In case of adsorption chromatography, adsorbent are the stationary phases, and you will see silica gel and alumina as the adsorbent. Mostly you will see this only. In your syllabus, so this is only silica gel and alumina, right? Next is mobile phase, your solvent, right? A mobile phase is allowed to move over the stationary phase, right? You will have different mobile phases here. The components of the mixture move by varying distances over the stationary. Now let us understand this with the help of a first type of chromatography, right? First type of chromatography, that is your column chromatography. Okay, that is your column chromatography. Let us say, for example, this is your that tube. Okay, this is your that tube. Now let us understand this. This is your first tube, this is second tube, this is third tube. Now beta, this is very simple. Dekho. This is your tube. Firstly, you will have three things: mixture, adsorbent, or you can say stationary phase, and third is your mobile phase, right? Or you can say that is your solvent, right? So firstly, though, this is wool, so that this whole material should not go down, right? Now here you will have your adsorbent, right? Can you see this with a diagram? Can you see this? This will be your adsorbent. This is your adsorbent, right? Or you can say this is your stationary phase, right? That is your adsorbent. What is this? This is the mixture of components. For example, ink or anything you have. I am taking mixture, for example, that ink is made up of three mixtures, three things, A, B and C component, right? So that is your mixture here. You have your mixture here. You have your mixture beta. And then there is the solvent. There is the solvent. There is this suitable solvent for the mixture. Now this solvent will depend on the mixture, right? The solvent will depend on the mixture. Now beta, what you will see? What you will see? You will see the adsorption of the components on the adsorbent. Okay? The adsorption of these components on the adsorbent, right? So let us see. It involves separation of mixture over a column of adsorbent packed in a glass tube, right? You have different columns here, right? You have solvent, this and that, right? Over a column of the adsorbent packed in the glass tube. You have this adsorbent that is packed in the glass tube. Column with stopwatch at its lower end, right? Stop clock. Stopwatch means stop clock. This is the stop clock. This is the stop clock. Okay, this is the stop clock. This thing is the stop clock, right? Basically, this is your column. Okay, this is your glass tube, right? And this is the wool. And this is the wool, right? Okay. Now let us see. The mixture placed on the top of the adsorbent column packed in the glass tube. Okay. This is your adsorbent and the mixture is placed above the adsorbent. Beta, these things are asked in the exam, right? This is adsorbent, this is mixture. They will ask you what are the layers. Layer is first is adsorbent, then you have mixture, then you have solvent, right? Now what will happen? Now let us see what will happen. Now eluent beta, I told you, eluent is nothing but mobile phase, right? Or you can say this is your solvent, or this is also called solvent, right? Different names beta they have used, just that to confuse you. Eluent, which is liquid or a mixture of liquid, is allowed to flow down the column. Now we have added solvent here. Now as soon as I add the solvent, the adsorbing powers will change here, right? Let us see. It will initiate the process here. The most readily adsorbed substance, very most important line. This is the most important line. Most important line here. This is the most important line. Mark it DM. If they want to ask question, they will ask from this line, right? They will ask from this line. The most readily absorbed out of A, B and C, one will be readily. I want to get absorbed first. The most readily absorbed substance are retained near the top and others come down various distances in the column, right? That means the one the one which is readily absorbed will be, beta, just remember one thing, the one that is readily absorbed will always be near to the solvent. That this will be applicable in all the chromatographies, right? You don't need to remember this thing, just remember absorbed will be near to solvent. In all the cases, adsorbed will be near to solvent. I'll tell you why I am saying this. Just note down this line in your notes. Adsorbed, which is readily absorbed, that will be near to the solvent, right? So now, if you have to write down the adsorbing powers here, we know that A is, this is A, this is A. For example, they have given you A, B, C, this diagram. Okay? In the exam, they have given you this diagram. They will ask you which has the maximum adsorbing power. So maximum adsorbing power will be of A, then it will be B, then it will be C. That becomes your adsorbing power. Okay? That becomes your adsorbing power. A, B, and then C. Right? One which is near to the solvent will have maximum adsorbing power. Right? Okay? Chalo. Yes, that is also important. Now, second kind of chromatography is thin layer chromatography. Now, with thin layer chromatography, just give me a minute. We will start to do that. Okay? We will do that chromatography here. Right? Because they can ask you questions from thin layer chromatography. So in thin layer chromatography, you have this kind of thin strip. Okay? Thin strip is given to you in the exam hall or your practical classes. And then what you must have seen, always your teacher will say, you should have a line 2 centimeter above the bottom. This is your bottom. You should have a line which is 2 centimeter above the bottom. Right? So I will just put one line over here that is 2 centimeter above it. Okay? So this is one line that is 2 centimeter above it. Okay? Now this line that is 2 centimeter above it is called baseline. What is that called, beta? This is called the baseline. This line is called the baseline. Okay? This is bottom. This is baseline. This is very important. If they ask you question, baseline and bottom, the difference in baseline and bottom is 2 centimeter. It is fixed, right? So they will not ask you to draw any line from the bottom. They will definitely say that 2 centimeter from the bottom, that is your baseline, right? And you will have ink on this particular thing only. Okay, on this line, you will have your ink. You will have your drop of your ink on this particular line. Okay, on that you will have a drop of your ink or whatever you are doing chromatography for, right? That mixture, it will be on that baseline, right? Okay. Now what you will do? Now, beta, what you will do? For example, this is your beaker. Okay. Acha, one more thing I forgot to tell you. This is not a normal thin, this is not a normal thin strip. Okay, what you will add here, you will have a paste of stationary phase, that is silica and alumina. You will make a paste, and in the lab they will give you a paste, and they will say firstly to add that paste. In sometimes, beta, it is already added, and sometimes they ask you to add it, right? Okay, in different labs there are different things goes, right? If your lab is very advanced, then they will give you strip, and which is already, there will be a stationary phase already in there, right? But when I used to do it, we used to apply this on the strip, right? After applying it on the strip, right? So what you have to do, this is your stationary phase. Okay, mixture is present here, and stationary phase is over that, on that thin layer, right? Now this is your beaker, hai na? This is your beaker. Now what we used to do na, we used to stick some kind of ribbon or something, right? And we used to, for example, we used to do this thing, hai na? We used to do this thing. We used to do this thing. For example, this is your, hai na? This is some pen or something. We used to stick it like this. And still I am not able to do that. We used to, create a hole with a pen or something, and we used to just without any, it should not, there should be no disturbance when it is actually put here, right? When you have put it here, right, it should not change its space, right? Because if it changes, your chromatography will go wrong, right? So what we used to do, we used to have something, some pen or something, where we used to stick this particular thing, and then it used to hang in air, right? Now the problem is what we will have in this beaker. In this beaker, we will have the mobile phase or your solvent, right? In this beaker, you will have your mobile phase or your solvent, right? So you will just hang it in the air and you will have your mobile phase over here. Now, very beautiful thing about this is you should not dip it entirely in the solvent. You should dip it just to that baseline. That amount of solvent should be added so that you can dip it just to the baseline, just to the baseline. Okay, they can ask you that also, right? Just to the baseline you should dip it, right? And after some time, 10-15 minutes or maybe sometimes 1 hour, depending upon the adsorbing powers, what will happen after some time, what will happen, you will see these kind of different colors over here, है ना? Different colors you will see. This kind of thing you will see, है ना? You will see different colors, red, blue, multicolor shade you will see in this particular strip, right? That means chromatography has happened. The component has separated themselves, right? So now beta, tell me one thing, that when we were talking about glass chromatography, है ना, that glass tube chromatography, in that what you had, this was your apna stationary phase, or you can say adsorbent. This is important, okay? The comparison is important. Then you had mixture, and then you had, this was your solvent. But when I'm talking about this particular thing, this is your beaker, and this is your that strip, right, which you have placed. This is your baseline. Now we know that this is our solvent, this is our mixture, and this is our adsorbent, right? I told you one thing, that if they ask you the adsorbing power, just remember one thing, what I told you. If they ask you the adsorbing power, you just need to remember one thing, that will be applicable to both the cases, right? And what was that thing? Adsorbing power, more the adsorbing power, or you can say adsorbing power is directly proportional to distance from solvent. Which have more distance from solvent, not adsorbing power will be more for that one which is near to solvent, okay, which is near to solvent. We know that in this case, if you have A, B, C like this is your A, this is your B, this is your C, then A is near to adsorbent, so it will be A is greater than B is greater than C, right? This is your adsorbing power. In this case, if you have A component here, B component here, C component here, now tell me what will be the adsorbing power. Now tell me, just apply this particular thing, that adsorbing power is near to the solvent. Which is near to the solvent? C is near to the solvent. So that means C will have more adsorbing power than B, then A. Beta, tell me, is that clear to everybody? And they can ask you the adsorbing power comparison of your thin layer chromatography and your column chromatography. You can write here, this is for column chromatography, this is for column chromatography, and this is for your thin layer chromatography. Now beta, tell me, is that clear to everybody or not? Is that clear to everybody or not? Right? Okay, understood that thing? I think now you will never forget about this. Whether they ask you thin layer or anything, any diagram they give you, any compound they have written here, just see which is near to the solvent. You just need to remember that in the column chromatography, solvent is above, then you have mixture, then you have adsorbent. But in this case, firstly here you have solvent, then you have mixture, then this is your adsorbent. Okay, that is the difference between both of these. Right, beta? Understood? Now tell me any problem here. Acha. Thin layer chromatography. Acha. This was separation of substances. Now let us see what is written in the theory part. Separation of substances of a mixture over a thin layer of adsorbent coated on the glass plate. What we have done, beta? What we have done, we have coated that thin layer on the glass plate, on this, not glass plate, on this, this is actually a glass plate only, at which I am taking it as strip only, right? So this is a thin layer, right? A thin layer, which is a thin layer about 0.2 millimeter thick. Now, how much thin? It should be 0.2 millimeter thick, not thick, it is thin only. Okay, that kind of layer should be pasted here. Of an adsorbent, that is silica gel and alumina. As I told you, beta, in that phase there was also same adsorbent, but the way the adsorbent is kept in both of these apparatus is different, right? So now next is the solution of the mixture to be separated is applied as a small spot about 2 centimeter above the end of the TLC plate. This is the end, that means bottom, and you will apply like above 2 centimeter, you will apply that line, and to that line you will add that dot here, right? Then the glass plate is then placed in the closed jar containing the eluent. What is eluent, beta? That is solvent only, है ना? As I told you, here you will have your solvent, है ना? Here you will have your solvent over here. This is your nothing but solvent only, right? Next is thin layer chromatography, beta. As you can see that, है ना? As you can see that here as well, right? This is your that closed jar, right? Where this is your solvent, this is your solvent, and it's not like we have filled the solvent to this much extent. We will fill the solvent below baseline only, and this is your baseline, this is the mixture, this is the adsorbent, this thing, this paste here will be the adsorbent, right? And after some time, what you will see, due to the capillary action, due to the capillary, what is capillary action? You must have studied that in physics as well. Capillary action is against the gravity. When something is moving against the gravity, right? So the ink will move. We know that usually though it should flow down. Na? Gravity means going down, but it will move up, right? Against the gravity, that is the capillary action. It will move up, right? So because of the capillary action, this ink will be distributed here somewhere. Different colors will be there, right? Okay, ji. Now, acha. Next is, as the eluent rises up the plate, है ना? Now, beta, this is also important that eluent is also rising up the plate. That is why we will have one numerical based on this also, right? So that is regarding the retardation factor. We will see one numerical. Okay, they can ask you one question regarding retardation factor, right? There are some things that are little twisted but easy only, right? So now, as the eluent rises up the plate, beta, now see one thing, when you have added this to this one, right? It's not like this mixture is only rising up. Even the solvent that is placed here, that is also rising up. That is also rising up. So I will make now one diagram for that. And I will make one diagram for that. For example, this is your plate. This is your glass plate, right? This is your glass plate. Now, after 2 centimeter, you have your baseline. है ना? To this baseline, you have a mixture. You have a mixture. This is your mixture. This is your mixture. Now, understand one thing, that you have to know 2-3 things here, right? For retardation factor. For example, the solvent has risen to this extent. Not to this extent, for example, to this extent. This is your rise of solvent, right? From the baseline, okay, we will see from the baseline how much distance the solvent has covered. That means the eluent has covered, let it be x. and you have three components of this mixture, that is A, B and C. This is B, this is C. Now from the baseline, A has covered A distance, B has covered B distance and C has covered C distance. Beta, firstly tell me, are you able to understand these three terms here? From the baseline, what is happening? This is from the baseline. This is your bottom. This thing is called the bottom. But when we will solve the numerical, we will solve that from the baseline. So even if in the question they will give you from the bottom, you will subtract 2 from that. For example, in the question, they have given you that your solvent is moving from the bottom, it is moving 12 centimeter. Now tell me, from the baseline, the distance will be 12 minus 2 centimeter, that is 10 centimeter. That means what I am saying here is, you don't have to calculate from the bottom. You have to calculate the distance from this baseline. If they have given you from the bottom, you will subtract this 2 and you will get this distance from the baseline. Right? From the baseline. Okay, ji? Now let us understand the retardation factor. Right? Chalo. The components of the mixture move up along the eluent to different distances depending upon the degree of adsorption and the separation takes place. As I told you that the components components of this mixture A, B, C are also moving above and the solvent is also moving above. Right? So you can write it down in your notebooks. What is the distance of solvent and water? Now, one thing. Tell me, what is the adsorbing power? Adsorbing power, we know that this is near the solvent. So C has more adsorbing power than B. Then you have A. This is your adsorbing power. Now this to we know. The relative, now this is important. The relative adsorption of each component of the mixture is expressed in terms of retardation factor. And from this you can also write one thing here, that adsorbing power is inversely proportional to retardation factor. It is inversely proportional to retardation factor. Now we will verify this also. Right? Okay? Adsorbing power is inversely proportional to the retardation factor. For example, they have given you to calculate, they have not directly given you the ABC, which is moving fast and down. They have just mentioned you the values, right? A has moved by a distance this, B have moved by a distance this, C has moved by a distance this, and solvent has moved by a distance this. Then you have to calculate the retardation factor and the adsorbing power. So how you will do that? Okay. So basically, as it is written here also, distance moved by the substance from the baseline, distance moved by the solvent. Here you can write, instead of substance, you can write component. Okay? So with this particular formula, we will derive, let's do one numerical based on this. Okay? Chalo. Let's do one numerical based on this. I am keeping it here and we are doing a numerical based on this. Right? So the question is, solvent from bottom, distance of solvent from bottom is 14 centimeter. Distance of component A from baseline is 10 centimeter. B from baseline is 8 centimeter. C from baseline is 4 centimeter. Okay? Now you have to tell me what is the retardation factor or of all of them. Right? What is the retardation factor? Chalo shabash. Everybody in the chat box. What is the retardation factor? Any idea about it? Everybody in the chat box, any idea about it? Retardation factor you have to tell me. Okay? Dekho. Now, this is from baseline. This is also from baseline. This is also from baseline. But this is from the bottom. So, in retardation factor, in the formula also, you will see it is from the baseline. From the baseline, not from the bottom, right? So, we have to convert it into baseline. Baseline is 2 centimeter. They have given you from the bottom, from this to this distance, that is 14. From the baseline, it will be -2, that is 12. So answer will be 14 minus 2, that is 12 centimeter, isn't it? 14 minus 2, that is 12 centimeter. Everybody in the chat box, tell me, is that clear? Tell me, is that clear? Right. Now we will calculate the retardation factor of different things here. Now we will calculate the retardation factor here. For example, if I talk about retardation factor of component A, I know the distance of this component is 10 and for solvent it is 12, right? Now retardation factor of B, the distance of B component is 8 and that of solvent is 12. Retardation factor of C, retardation factor of C, the distance is 4 divided by 12, right? Okay, chalo. Now tell me which retardation factor is more, which is less. Now everybody in the chat box, tell me which retardation factor is more, which retardation factor is less. Hanji, you have 10 by 12, you have 8 by 12, you have this, so it will be 5 by 6, it will be 4 by 6 or 2 by 3, okay, 2 by 3, this is 1 by 3, right? Now tell me, beta, which retardation factor is more, right? Now see, can you verify this thing, that how retardation factor is inversely proportional to the adsorbing powers? Everybody in the chat box, let me know. Beta, calculation to do na. Which is more here? A, B, C, which is more? Which is more, beta? Just tell me the retardation factor here. Which is more, which is less? Tell me the retardation factor, which is more, which is less? A, B, C, right? This becomes the retardation factor, right? A, B, C, okay? And we know that adsorbing power is inversely to that. So adsorbing power will be C, B, A, right? Okay, beta, understood? We have also verified this, that how C is more adsorbing as compared to B than A, right? Okay, understood? Maximum they can ask you this kind of numerical, right? Okay, ji, chalo. Now, rest part is, wait a minute, let me see if the mic is still on. Yes. Now, next is, let us see some other theory parts of this thin layer chromatography. The spots of colorless. Now, this is very, very important. If you have, I told you now in the starting, that chromatography, usually though it was because of the color that it was giving us. But now it is also used for separating those components which are not giving us colors. Then how we identify that we have separated that? We have some other further methods for that. So these are the 3 methods mentioned in your NCERT, right? As I told you, from this chapter, apart from NCERT, they will not ask you anything, right? So 1, 2, 3 methods you have. The spots of colorless compounds can be detected by, first is putting the plate under UV light. First method is to put that plate. They can ask you which of the following is not a method to identify colorless chromatography, right? First is, that is true, that is your UV radiation. And now you can put it under the UV light and it will start to show different colors, right? Then another detection technique 2 is to place the plate in a covered jar containing crystals of iodine, okay, right? Third is very important and a very specific thing. Some appropriate reagent is also used. For example, this is exactly mentioned in your NCERT. So this becomes very important. Amino acids may be detected by spraying the plate with ninhydrin solution. They will ask you how you will separate the amino acids. The answer will be by ninhydrin solution. In the chromatography, how you will visualize that, that will be by ninhydrin solution. That is for amino acids. You don't have to remember for all the compounds out there, because what is mentioned in your NCERT, that is important. Those examples are important for you, right? Okay, chalo. Now last is your paper partition chromatography. So it's like a paper only. It's like a paper. Okay? For example, I have one paper. Let me take one paper here. Okay? Let me take any paper here. Chalo. So I have this paper. Okay. So the paper that is used in the paper chromatography, everything is same. Just like thin layer chromatography, it is same as thin layer chromatography. The only difference is it does not need any paste of adsorbent, right? That is why it is not called adsorption chromatography. Why this is called partition chromatography? Because inside it you already, this is a different paper. Already you have water trapped in it. That is why this is also called cellulose paper. Okay, this paper is also called cellulose paper. This is not like a normal paper you will use. You will use cellulose paper that will be provided to you in the lab itself, right? Adsorbent is already trapped in that paper, so you don't have to provide external adsorbent here, right? Everything else will be exactly same, exactly same. You will have a, for example, I am making this as my paper. Okay, I'm making a very chota paper. Okay, so now the same thing I will do. The same thing I will do. Let us see. Same as we did in thin layer chromatography. It adsorbent is already there. We will put it in that solvent, right? And that will be separated, right? Same thing we will do. So let us see. Let us see. Wait a minute. Let us see that. This method is based on the continuous differential. Firstly, to beta, principle is important for you, right? Principle is important. Principle, this principle. Okay? This method is based on the continuous differential partitioning of components of the mixture between stationary and mobile phase, right? Differential partitioning is there. In paper chromatography, a special quality paper, chromatography paper is used, or this is also called cellulose paper. Chromatography paper contains water trapped in it, which act as a stationary phase, right? Which is acting as a stationary phase. You can also write this is also called cellulose paper. A strip of chromatography paper is spotted on the base with the solution of the mixture. It is same thing. Okay. This solvent act as mobile phase. Which is the mobile phase? That is in the jar, in the beaker. Okay. Now the solvent rises up the same way. है ना? For example, you have this one. है ना? You will have a baseline. And then you will add some mixture here. My marker is also stopped working. है ना? Then it will, with the capillary action, it will move above. है ना? My marker has stopped working. So kindly adjust. Right? So this will move above just like thin layer chromatography. The solvent rises up by the paper by capillary action, right? And flow over the spot. This paper selectively retains different components according to their different. But the only difference here is, there we were talking about the stationary phase and their adsorptions. Here we are talking about partitioning factor, differential partitioning factor. What is that? That is not important for you. Just remember that this is based on the partitioning factor, right? So here, differing partitioning of the two phases, right? That is the principle. This is no adsorption, nothing is used here, right? The paper strip so developed is known as chromatogram. Like you have your Instagram, this is their chromatogram. Okay, this is called chromatogram. The spots of the separated color components are visible at different heights from the position of the initial spot of the chromatogram. Okay. Now, beta, this is same as that we have done in thin layer chromatography. Now, in that case, you had one glass tube, a glass plate, and here you have a chromatogram, a paper where water is trapped, and the difference is here we have different partitions of the phases, right? Because of that, this is your dot that will be separated out on that paper. Okay, everything else is same. Okay, ji? Okay, beta. Here we don't say adsorbing power. Adsorbing power is not used. Adsorbing power term is not used in partition. The term that is used is different partition of two phases, right? Okay, differential partitions, right? Okay, bacha. Okay, is that clear to everybody? Now, beta, we have completed purification, right? We have completed purification. Now, after that, we will start with the qualitative analysis. Then quantitative analysis. Now, that will become really simple for you because I have already concluded that for you, right? So, that will be very, very simple for you, right? And learning the precipitates, the colors, the compounds. I have made a table for that, right? With that table, you can understand a lot of things, right? Just with the help of that table, it will become very simple for you. Okay, chalo. Now let's have break, right? And I'll give you break of 15 minutes, right? Or 10 minutes, 10 to 15 minutes break. Now it is 1:15. I'll see you at 1:30, okay? So that you can also have your lunch. Okay, you can also have your lunch and take a rest, because after that we are going to do qualitative, quantitative analysis, not a very, as you will see, ma'am, 2-3 hours you are going to take. I told you now, I have already concluded that for you. Right? Okay. And today we will do the PYQs also. So I will see you at 1. Even the blackboard is like, I need rest. Chalo. Chalo. But I think it also needs rest. So I am giving you break now, and to this digital board also, and to myself also. Okay, I'll see you at 1:30 p.m. Okay, so guys, I am back. Am I visible? Am I audible? Yes, bachcho, I am visible. Am I audible? Let me know in the chat box if I am visible and audible. So we have completed purification and now we are going to do qualitative and quantitative analysis. Okay, ji? Chalo. So let us start qualitative and quantitative. I don't know why this is not working. Yeah, okay, it is. Chalo, now it is working. Now, beta, let us talk about qualitative, quantitative analysis. If you talk about qualitative analysis, that means you want to see what kind of product, how can you do the detection of these particular compounds. For example, in the exam, what they will give you? They will give you one organic compound, right? They will say, if we don't know what is the name of this organic compound, you have to identify which compound is that. Thank you so much, bachcho. Thank you so much. So, beta, now you have to identify which compound is there. Oh my God, you have filled the chat box with so many green hearts. Thank you so much for that. Okay. So now, beta, what you will have in the exam or in the practical exam or whatever, what in the lab, what they will give you a organic compound. They will just say that you have to identify that what kind of atoms are there in the organic compound. We know that in organic compound, we have hydrogen, we have carbon, that is definitely there. Right? That is why we don't do any detection of carbon and hydrogen, that will definitely be there. Okay, we'll see these two things, right? That will always be there, carbon and hydrogen. Then you will have nitrogen, or you can have oxygen, you can have sulfur, you can have phosphorus, different things you can have in your organic compound, right? So we'll see that what are the tests to distinguish between these, right? And these tests will be very important when you do your practical chemistry as well. So now let us start with this. First is Liebig test. In Liebig test, what you have the identification of carbon and hydrogen, right? So how to identify carbon, how to identify hydrogen? So we know that in the organic compound, for example, we are reacting this. This is your organic compound, okay? Now, it is reacting, for example, you have carbon and hydrogen in it. Okay, I'm writing it here. You have organic compound that has carbon and hydrogen in it. When carbon is reacted with oxygen, it will form carbon dioxide. When hydrogen is reacted with oxygen, it will form water, right? When hydrogen is reacted with oxygen, that will form water. So that means when we react these things with oxygen, you will have the formation of your, you can just not say copper, instead of this we use copper oxide, okay? Copper oxide. You will have the formation of carbon dioxide here, and with this you will have the formation of water. Because hydrogen will react with oxygen, here carbon will react with oxygen. They will give us carbon dioxide and water here. This is your carbon dioxide and water here. Now, how will we identify that carbon dioxide and water has been formed here? Carbon dioxide is a very general test that you used to do in lower classes also. That you have a quicklime, with quicklime, with that you have slaked lime, right? CaOH twice, right? That's slaked lime. When you pass carbon dioxide into that, you will get white precipitates of carbon, you will get white precipitates of calcium carbonate, that is CaCO3. So that is a very old process that we used to do. That how will you identify carbon dioxide, because it is not visible. You can only firstly, so you will see brisk effervescence. Whenever you will be carbon dioxide will pop out, you will see brisk effervescence, right? Second thing is that to confirm that test, we will pass slaked lime into it, and slaked lime is CaOH twice. That is your slaked lime. You can write it here. Slaked lime, and you will get, what you will get from here? You will get calcium carbonate, that is white precipitates of calcium carbonate will be formed here. Understood? You had one organic compound. What you did, you reacted it with CuO, copper oxide. One thing will be formed as carbon dioxide, other thing is water. Right? Water is with hydrogen, carbon with carbon and copper oxide, you will have carbon dioxide. For carbon dioxide, you use this identification process, and for water, very simple identification process. Water will behave as a water of crystallization. For example, you have CuSO4, which is anhydrous copper sulfate. Anhydrous means it will be colorless, है ना? It will be white in color. That means there is no water of crystallization. But when you are adding this thing that you have taken out, right? We don't know whether it is water. We cannot just drink it, right? What if it is a different compound, right? Out from this world, right? So we don't want to do that in chemistry lab. Okay, is this water? Let me taste it. You never do that, right? There are so many colorless liquids out there. You can't drink everything, right? What if there is some other compound that is formed, right? So what we will do, we will react this with copper sulfate, anhydrous copper sulfate, and it will attach as a water of crystallization to form CuSO4 dot 5H2O, which is blue in color, right? We know that crystals of that are blue in color, right? So that will be blue in color, and hence you will have the identification or detection of hydrogen and carbon in the organic compound. That was the first test, right? Okay, so don't drink anything in your lab, not even distilled water. That is also not good, right? Okay, our body cannot digest that. Okay, chalo. Next is Lassaigne test. Lassaigne test. So Lassaigne test is very, very important. Very, very important. Very, very, very important. Right? Write DM here. Very important. Now, this test is very important. Firstly, I will explain you what exactly we will do in the lab. Right? So, beta, I have one. You can take it as a fusion tube. Basically, this is not a fusion tube. This is how fusion tube looks like in the lab. This is how a fusion tube will look like. Okay, you must have seen that in lab as well, right? If you have not seen that, that's why I'm showing you that, right? So what you will do, sodium, we know that is very easily, we can cut it. We can very easily cut sodium. So we'll cut sodium, and then we will, with one little piece of that sodium, we will put that with the help of a spatula, we will put that inside that fusion tube, right? Okay, this is a very, very, very thin tube, very thin tube. So we will put that in that fusion tube, right? After that, what I will do, I will add the organic compound that my teacher has given me, right? For example, I have given you one organic compound. You will say, okay, ma'am, I have put here sodium also. Now I will add one organic compound, just a little bit of that organic compound into it. Now I will use the, there are different instruments in the lab, right? So what I will do, I will just start heating it, right? In that burner, I will start heating it. So what will happen? You will say, ma'am, we will start heating that tube. That is a very small tube. That is a very small tube. At one point, it will start to look like a black tube. This, with so much of heating, it will start to give that carbon thing outside it. Okay, it will be heated to that extent. Now, then what you will do, you will have a beaker. Inside that, what you will do, you will just put that into that. There will be solvent or water. Then what you will do, you will put this hot fusion tube into that beaker, and a sound will come, and to that sound, this fusion tube will break, right? And that is called the sodium extract, or that is called Lassaigne extract, right? That is called our Lassaigne extract. Basically, why we are doing that? What is the need of doing that thing, right? What is the DM is Diksha Madhumati na ma'am. Okay, yeah, you can say anything. Doctor ma'am is also nice. You can talk. You can say Doctor ma'am to me. Okay, Diksha ma'am, Doctor ma'am, everything is fine with me. Now you have this fusion tube, right? Now you have this fusion tube will break, and after that, one mixture will be formed, right? Now you will have the pieces of glass also in that mixture. So many things will be there. You will filtrate it out, right? And you will have the residue, right? Now that thing is called the sodium extract. That thing is called the sodium extract. Now why we need to do it? Tell me, why we need to do it? Everybody in the chat box, why we need to do it? We need to do it because organic compounds have covalent bonds. We all know that organic chemistry we have studied. We are studying about covalent bonds only, right? In all the organic chemistry. But to convert that into ionic bond, we make a sodium extract, right? So basically what happens here, this will be converted into, for example, this, see, there will never be in an organic compound. Why I have written carbon and nitrogen here? Because this is only how you can detect it, right? The sodium extract, the sodium will react with both carbon and nitrogen to form NaCN. This is observed experimentally, that NaN cannot be formed, NaC cannot be formed, NaCN is formed, right, with the sodium, right? This is the sodium extract. In the sodium extract, you will have this thing. If in the organic compound there is nitrogen present, if in the organic compound sulfur is present, then you will have Na2S. If in the organic compound some halogen is present, then you will have NaX, right? These three things, this is present in the sodium extract, or you can say fusion extract, sodium extract. Okay? Okay. Now let us see the theory part here. Okay. And today's class is interesting. Yeah, today's class is actually very interesting. Students usually ignore this chapter. They are like, we don't want to do this chapter, right? But this chapter is very simple, right? Because in last year, I think last year JEE Mains, they have asked the question from this chapter, right? And at times they also ask, sometimes surprisingly they ask question from this chapter, and a very simple question is asked, right? So if we can give 3 to 4 hours to this chapter, I think, and getting 4 or 8 marks from that, it's okay, right? So because it's not like they will ask you a very difficult question from this chapter, a very simple question will be asked from this chapter. Okay, so now let us see the theory part. Lassaigne test. First is take a small piece of dry sodium in the fusion tube. I told you this is your fusion tube. Again, I am saying this. Okay, this is your fusion tube, right? I'll take one sodium, heat the tube slightly on the Bunsen burner. Okay, you will start to heat that tube, right? So that the sodium melt. The sodium will melt. Add a pinch of organic compound, and then you will add a pinch of organic compound. Then again you will start heating it slowly. Heat it slowly to start with, so that the compound reacts with sodium metal and tube becomes red hot. And this tube will become really red hot, right? So in that case, now you know that I cannot touch it. Then now what you will do, the red hot fusion tube is then plugged into distilled water, right? You will just put it in the distilled water. What will happen? A sound will come and this tube will break, right? The filtrate is called now this, and then cooled and the filtered. This will break, and then what you will have, you will filter it out. And after that, that filtrate will be called, the filtrate is called sodium fusion extract, or also called Lassaigne solution. Okay, and that is how you will have this sodium that was in the tube. This was the organic compound. I can write in here that these things are from the organic compound. This is from the organic compound. This is what we will make. Now all the compounds that are made are ionic in nature. Now, because ionic bonds we can detect easily, covalent things are difficult to detect. That is why firstly we have converted that into ionic compound, right? Okay. Now we will see different test for, now beta, it's not like they will say, hi, I am sodium, hi, I am carbon, hi, I am nitrogen. It's not like they will themselves say, yes, I am NaCN, I have been formed. I am Na2S, I have been formed. And I am NaS, I have been formed. No, they don't talk, right? That is the thing. Chemicals don't talk to us. They don't say, hi, I am Diksha, hi, I am Madhumati, hi, I am Tanuja, hi, I am Sumi. They don't talk like that. So what will happen? We have to detect them, right? We have to detect them. How will we detect? So now we will see the processes, how to detect these three things here. Now the cramming part will start. Okay, now you will start hating this chapter, right? Because the cramming part is going to start and you will like, ma'am, what, yeah, we just praised this chapter and now this chapter is doing so bad to us. But don't worry, right? With revision and with masti, we will try to understand this and we'll try to learn it here in the class itself, right? So for example, you have NaCN. What you do? You react this with FeSO4. What you do? You react this with FeSO4 and this compound is formed, right? This is Na4, very important, Na4 bracket, this is a coordination compound, okay? Na4FeCN6, okay? This compound is formed. But this compound does not have a specific precipitate color, right? So we won't be able to identify this compound. So relax, what will happen now? And this is not a very stable compound, right? What will happen here? We know that this is your Fe, this is your Fe2 positive, right? It will get converted to Fe3 positive, right? It will get oxidized in the mixture itself. In this mixture itself, it will get oxidized to Fe3 positive. So it's not like I have added Fe3 positive externally. Inside only this Fe2 positive will get converted to Fe3 positive. It will get oxidized. There will be reaction, different reactions happening there. Now this Fe2 positive which has been converted to Fe3 positive, it will react with this compound that you have made. And now you will have the formation of a new compound that is very, very important, which is called Prussian blue color. Prussian blue compound. So I also showed you one painting of this particular color, right? That was very famous painting and you must have seen that painting like so many times. That is also in some movies also they show that painting. It's of blue color entirely. Some white, some yellow suns, something is made here. It's like a, for example, you have so many mountains, blue color mountains are there. It's a very beautiful painting, right? So that was made by Prussian blue color, right? Because we don't want it to get oxidized. That is why we were using coordination compound. And here that coordination compound is formed, right? Here that coordination compound is formed here. So this is your iron Fe4, Fe, then CN6. This becomes your Prussian blue, right? Okay, so we have studied about this. You can, okay, yes. Okay, beta. So that was the test for when you have nitrogen. Understood one thing? First step is very simple, that you will make a Lassaigne test, or you can say you can make a fusion what is that called? Extract. Okay? Lassaigne extract or fusion extract you will make. After that, there will be different tests to identify whether it is nitrogen only. For this, you will make Prussian blue color. Prussian blue color will be formed. That is, Prussian blue will be formed here, right? With the help of, with reacting with FeSO4, right? That is the first thing. This is a very, very important thing. Very, very important thing. Second test is test for sulfur. Now let us see the test for sulfur. With sulfur, you have two tests and both of them are very important, right? Both of them are very important. So when Na2S is reacted with lead acetate, okay? This is acetate group, CH3CO. This is acetate group. So when this is reacted with lead acetate, you have the formation of PBS, right? And PBS, we all know that is black in color, a black PPT is formed. A black precipitates is formed here, right? So then you will say that yes, if for example you have no idea that in this beaker, for example, here you have filtered it out, you say, okay, this is some kind of solution I have made, I don't know what is there. Then what you will do? You will add lead acetate into it. And now when you add lead acetate, you will see, oh my God, there are black precipitates here. That means definitely there is sulfur present in the organic compound. In the lab also, they are very, very interesting. They are very, very interesting. I remember sometimes I used to do the organic compound detection in just half an hour or 1 hour, right? Sometimes it used to take 3-4 hours to detect the organic compounds, because it's not like you have to do all the steps here. First, you have to do for nitrogen. it will fail or it will pass. If it passes, then you don't have to do anything else, right? Then you have to do for sulfur, then for halogens. If all of them will fail, then you have to do for phosphorus, right? So that is why it's like depends on your luck, right? Sometimes it used to take us not 5-6 hours, but yeah, 2-3 hours. Sometimes we used to get free in just half an hour, like, okay, that was the very simple, right? Chalo. So now we literally used to pray in exams that please God give us some simple organic compound. Sometimes teacher used to give such complex organic compound, na? Oh God. Okay, so this is your PBS, which is of black precipitates are formed. This is very important, beta. That with sulfur you have PBS, right? PBS is formed. That is black precipitates are formed, right? In your mind, two things we have done. For nitrogen, Prussian blue is formed, right? With FeSO4. Here in sulfur, you have with lead acetate PBS is formed. That is of black color. Now, second one is, this is also very important. In this, you react this with, wait a minute, the name is also very important. That is sodium nitroprusside. Now, how to remember this thing? Beta, firstly, you have to remember the formula of sodium nitroprusside. Right? Sodium is Na2 Fe nitroprusside, CN5NO. Right? Now, you are reacting this with NaS. Now, this sulfur will go inside. That NO will become NOS. This sulfur will go inside and it will become NOS, right? And this Na, this is 2Na, this is also 2Na. So it will become 4Na in the product, okay? It is easy if you remember the formula of sodium nitroprusside. What is the formula of sodium nitroprusside? Na2, bracket open, right? Nitroprusside, that is FeCN5NO, right? After that, what will happen? This Na2 will combine together to form Na4 and this S will go inside the bracket, that is called NaOS. This is just to learn these reactions, right? Okay. So, with this what you will have? You will have a violet color precipitate. You will have a violet color, beta. The colors are very important. The violet color precipitate is formed here. Okay, violet color precipitate is formed here. That is the third reaction. Okay. Now, this is, for example, you have sulfur and nitrogen both. Okay? Sulfur and nitrogen both. Now, if you have both sulfur and nitrogen, what will be formed? NaCN is for nitrogen and S is for sulfur. So, you will have the formation of NaCN. This is your fusion extract. This is your fusion extract. In that fusion extract with the sodium, they have formed in the beaker, they have formed NaSCN. Now, beta, all the tests have failed. I have done nitrogen test, it failed. I have done then that test, that has failed. Okay. Now, I will see whether, because see, nitrogen and sulfur both are present. But in the fusion extract, you have SCN. So, SCN will not react with this lead acetate. SCN will not react with this sodium nitroprusside. SCN will not react with this FeSO4, right? So, nitrogen and sulfur both are present here. But still, they are not giving the test of nitrogen. They are not giving the test of sulfur, right? But the teacher is saying, but nitrogen and sulfur is present here. Now, which test you will apply? You will apply this test. Right? This is also a very important test. You will just react this with Fe3 positive and this SCN negative will react with this Fe3 positive and you will have a blood red PPT. Okay? FeSCN, you will have a blood red PPT of this compound, which is very, very important, right? Which color of PPT is formed, right? Okay, beta? Okay. Sodium thiocyanide plus FeCl2. FeCl3 na? Yes. Very good, Rathi. FeCl3. FeCl3 you will use here, right? And you will form this blood red PPT precipitate will be formed here, right? In case nitrogen or both are present in this, then sodium thiocyanate gives blood red color. Okay? Blood red color will be formed here. Okay, ji? Okay? Chalo. Next is nitrogen test got failed. sulfur test got failed, nitrogen and sulfur test got failed. Now you have halogen test, right? Now you have that sodium extract. You again have that sodium extract, है ना? You again have that sodium. हाँ beta, I will drink, don't worry. Okay, again you have that sodium extract. Now in the sodium extract, you are thinking, oh my God, ma'am, we are tired, ma'am. This we used to do. We used to do 5-6 tests and then we're like, I don't want to do this. I don't want to again do this, right? So, but after in the end, now when you will get your result, it was like a happy moment that yes, finally I got that result, right? So chemistry lab is like totally love. That's why I love teaching this chapter. Why? Because you know that make me remember my college days when we used to be in the lab and we used to like I think in our college we were the first to enter the college at 8 a.m. right? So we used to have our language class after so many classes till 2 p.m. Till 2 p.m. we used to have our classes, theory classes. From 2 to 5 p.m., 3 hours we used to have our lab. Oh my God. And all the other students of different branches, commerce, MBA, they like, you know, they were not there in the college. It was only us, medical and non-medical students who were sitting there in the lab doing these experiments. So it was fun. It was really fun. Okay. So now beta, you have sodium fusion extract. Now what we are doing, we are reacting this with AgNO3. Okay? Now for halogen, you just put this, you put acidified AgNO3. Okay? With silver nitrate solution AgNO3, what will happen? है ना? You will have different precipitates. I know halogen is of chlorine, bromine or iodine can be there. Okay? Chlorine, bromine or iodine can be there. Now, for example, I know that with AgNO3, this Ag positive and this X negative, they will combine together to form AgX. Now, this AgX can be of 3 types. It can be of 3 types, right? First is AgCl, then it is AgBr, then it is AgI. Now, depending upon the color of precipitate that is formed here, we will identify which halogen was formed, right? For example, you have the formation of white precipitates, right? For example, you have the formation of white precipitates. That means chlorine is present. For example, you have the formation of pale yellow. That means bromine is present. For example, you have the formation of yellow, bright yellow. That means iodine is present, right? If you have white precipitate, chlorine. Pale yellow, that means not very yellowish, right? Okay, it's like a pale yellow color. Okay, a very pale yellow, like a color of the khichdi. Okay, color of moongi ki dal. Okay, so or color of poha. That is a pale yellow color, very less, है ना, very less yellow, right? So in that case, that will be bromine. And this is your yellow color, like this, very bright yellow color. That means you have iodine in it. Now, sometimes we are not able to understand whether it is pale yellow or it is yellow, right? Or we are not able to understand whether it is white or it is pale yellow. Sometimes white, because of the impurities there, sometimes white might look like it is pale yellow, right? So, to identify that thing, we do further what we do, further beta, we dissolve, we add ammonium hydroxide, NH4OH. In sodium I am saying, ammonium hydroxide, some will be soluble, some will be insoluble. So, when you have silver chloride, that will be soluble. Silver bromide will be partially soluble, right? And silver iodide will be insoluble in that. So, in that way, you can further do the identification test to be sure that which halogen is present here. Okay, ji? Okay, beta? Yes, we have to perform experiments 4 days every week. Yes, even we performed experiments 4 days every week. And those 2 days also, we used to stay in college only. Huh? So, we used to stay in college only, other 2 days only we used to be there and sitting and relaxing. And there is turn-wise lab, there is turn-wise lab, because in lab, it's not like you have 100 students in your class and they will say 100 students will also go in the lab. It's not possible. That is why they make that circular thing that, okay, now today these 20 to 15 students will go in the lab. So we used to have fixed slots for that, right? And when there was like free day for us, then we used to like chill in the class, sitting there, and then coming home at 5 p.m. and then relaxing. What days, what beautiful days, है ना? Beautiful days of my college life. Okay, ठीक है जी, beta, is that clear to everybody? We have done which thing? For nitrogen, everybody in the chat box, shabash, shabash, shabash. For nitrogen, which was formed, Prussian blue color was formed. For sulfur, PBS, lead sulfide, black precipitate was formed, right? And with nitroprusside, which was formed, violet color precipitate was formed, where you have Na4, Fe, CN5NOS. Okay, that was the color of violet. Now, if you have nitrogen and sulfur both, in that case, blood red precipitates were formed of FeSCN, right? Okay, when we reacted with Fe3 positive. After that, we did halogen. Halogen is of 3 types. You will react it with the AgNO3 solution. Okay? After that, you will have the formation of AgX. AgX, if it is AgCl, then you will have white precipitate. If it is AgBr, then you will have pale yellow precipitate. If you have AgI, then you will have bright yellow precipitates. Okay, AgCl is soluble, then that is partially soluble, and AgI is completely insoluble in the ammonium hydroxide solution. Okay, okay, beta, revised everything, right? The Lassaigne test, beta, is that clear? Is that clear? I think you must have revised everything. Now only you remember few things here. है ना? When you revise it again, na, that will fix in your head. You will be able to retain it for a longer time in your head. So I would really advise you, I will send the notes on Vedantu NEET English channel, Telegram channel. Now, after go through the notes, especially for qualitative analysis. You don't have to go through the notes of purification because that is the very simple. But here, remembering the precipitate color, the formula, that is a difficult part, right? Students get confused in that. That is why I'm saying revise it in the evening or before sleeping or tomorrow morning, revise the notes of qualitative and quantitative analysis. Yes? Okay, chalo. Next part is, now this is a tough thing. Hai na? This is tough than that of Lassaigne's test. Now let us see. This is also under Lassaigne's only, but this is different. That is test for phosphorus. Here you don't make any sodium extract, nothing, right? So what you do here? Everybody, what you do here? The compound is heated. Now I know there are so many reactions here, but what you have to remember is this last reaction. This last reaction is very important for you. Okay? If you don't want to learn any of the reactions, it's okay if you don't learn this, but this is important. If you can learn all the reactions, that is perfect. But if you want to choose one reaction, that is a must to remember, then that is this particular reaction. This particular reaction is must to remember, and especially this compound you should know. This compound you should know which compound is formed. Because when we will do quantitative analysis, then you will need the help of these compounds. Qualitative and quantitative are linked to each other, right? They are linked to each other. If you don't know the end product, then you won't be able to understand quantitative analysis, because after that we will do formulas of this, right? And trust me on that, formulas, beta, you will just remember in this class only. You will thank me that, ma'am, you have made it very simple, right? I wish I could make these reactions also simple for you, but this is what it is, right? This is what it is. So the compound is heated with oxidizing agent. First you will heat it with any oxidizing agent. Sodium peroxide. The phosphorus present in the compound reacts with that and make a compound, that is sodium phosphate. Now, after that, what will happen? The solution is boiled with nitric acid. Again, it's a very good oxidizing agent. And then it is treated with ammonium. Now, this is important. This is important. This thing is important, right? That you have H3PO4, right? You have H3PO4. This H3PO4, the phosphorus, which was, firstly, we have to take that phosphorus. For example, there is in that organic compound, phosphorus is present. Hai na? Then, there will be yellow precipitate that will be formed in the end of these steps. If there is no phosphorus present, then there will be no yellow precipitate that is formed. And according to my what kind of question they ask in NEET, I don't think so they will ask you these reactions, okay? Either so they will ask you quantitative analysis from test of phosphorus, or what end result they can ask you that in the test of phosphorus, which product is formed, or which what is the color of precipitate that you will that will help you identify that there is phosphorus present in that organic compound. They will not ask you that full-fledged reactions here, right? So firstly, phosphorus with oxidizing agent, then phosphorus with nitric acid. In the end, you will have the formation of H3PO4. That is important, that you will have the formation of H3PO4. So you have to remember that H3PO4, right? That is reacted with, very important, ammonium molybdenate, right? Ammonium molybdenate is NH4 twice MoO4. NH4 twice MoO4. Mo4. Okay? NH4 twice. Here you have 4 and here also you will have 4. NH4 twice. Achha, you can remember this like this. Okay? You can remember it like this. NH4. We know NH4 ammonium, so it is ammonium only. If this is twice, now you will have 2O here. Right? And molybdenate, so we all know. Because here you have 4, here also you will have 4. This is a way to remember, yaar. It is just a way to remember things here. And what else I can do for you? I can just make you cram things here, right? So there is no other way to remember this, right? You have NH4 ammonium, you know, right? Okay. Then NH4 twice. Just remember NH4 twice, right? Twice, if there is 2 here, so that means 2 oxygen will be there. Okay? 2 oxygen will be there. That is this. Now, that means here you have molybdenum. So that is MO. MO. And here you have 4, here you have 4. Okay? 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 Okay, ji? Chalo. This is ammonium molybdenate. Now, you are converting this ammonium molybdenate to this ammonium phosphomolybdenate. How you are converting that? See. This twice will be thrice. Firstly, so you just remember one thing. Just remember one thing. NH4, you have twice MoO4. Okay? And you had here H3PO4. And third was nitric acid, HNO3. Reactants, so now you remember. Now you have to remember the yellow precipitate. Which yellow precipitate will be formed here? That is important to remember. See. Now what you will do, firstly tell me one thing. You will have 2 things. Ammonium phosphate. Okay? So, you will have PO4 3 negative here. This is NH4 positive. Tell me, are these 2 ions that you have seen? Hai na? What is PO4? PO4 has 3 negative charge. We all know that. Right? And this is NH4 positive. Ammonia always has positive charge. Now, when this cation and anion are making a compound, what will happen? Exchange of valencies will happen. So, it will be NH4. Right? This is thrice. And this is PO4. Okay? Dot. Dot. Now, we know that here you had 12. Right? Here you had 12. Or you just, if you don't want to remember this 12, you can say, acha chalo, remember this 12 only. Okay? Now, or you can also do one thing here. This is your MoO4. This is your MoO4. You take out from this MoO4, that will become MoO3. MoO3. And here, because 1 oxygen you have taken, there was MoO4 and here you have taken 1 oxygen. So instead of that oxygen, you need to replace one thing here, that is 12. But I know that is a very weird method to learn, right? But this is how you can learn things, right? This is how you can learn these weird, big formulas, right? And this is your yellow precipitate. Acha, try to write it in your notebooks if you're able to learn this. If you have a better method, then let me know in the chat box. Okay? Okay, ji? Okay? Beta, the color is, the final color is important for you. That is the detection, because this is, it's not like you are adding something and at every step you have to remember the colors. Not. Okay? As though everything will have different colors. In the end, you will just add this, then add this, then add this. In the end, you will have some differentiating color. You just have to remember that. That for phosphorus, you will have ammonium phosphomolybdate that will have yellow color. That's it. Okay? Chalo. Now remember, now beta see if you are able to draw this or not. Okay? Chalo, what we did, chalo, let me draw it with you. So everybody in the notebooks, let us see if you are able to, because this is the most difficult reaction of this chapter. Okay? So this is NH4. NH4 we know it is thrice. So it is NH4 and you have molybdate. So it is MoO4. Okay? Okay. Now this is with H3PO4 that was formed with oxidizing agent phosphorus with oxidizing and nitric acid. And here you have nitric acid. Okay? What you will have here, as I told you, NH4 positive and PO4 3 negative. They will cross multiply and you will have NH4. This is 3 and this is PO4. This is PO4. Everybody, I hope so you are also writing it, because I am writing this along with you. Only for you I am writing it. Okay. So this is NH4 thrice PO4. Achha, here it should be 4, not 3. Sorry, it should be 2 here. Okay? It should be 2 here. Right? NH4 twice. Huh? So this is NH4 thrice PO4 dot, what it is? MoO4. Instead of MoO4, write MoO3. And replace this oxygen with 12. And this is of yellow color. And this is of yellow color. Acha, tell me. Now everybody, are you able to remember this? Hana? Have you tried this in your notebooks or not? You must try this in your notebooks as well. Okay? Okay? Done? Done, bacha? Chalo. So now, next is, this chart is very, very important that I have specially made for you. Okay? This chart is very, very, very important. If you remember this chart, the questions of qualitative analysis will become very simple. It will in the slaked lime and you will have calcium carbonate that is of white color. Right? Hydrogen, we know that with CuO. Achha, if you want to see the reaction also, I am writing the reactants also. With CuO, this is also with CuO. With CO, it will give us H2O and that is reacted with copper anhydrous copper sulfate to form blue color of hydrous copper sulfate. Right? That is formed. Third is nitrogen. For nitrogen, we have Fe2 positive, or we can just say FeSO4 is reacted, and hence you have the formation of Prussian blue, right, which is giving us Prussian blue color, right. Next you have sulfur. Acha, with sulfur you react this with two things. If you react this with the lead acetate, that is, we don't have space for that. Chalo. If you react this with lead acetate, that is PbCH3COO twice. Okay? If you react this with lead acetate, what you will have? Acha, everybody, you will have PbS, that is of black color, right? Acha, if you have other method is sulfur with which thing? Sodium nitroprusside. And what was sodium nitroprusside? Na2. Shabash beta. Abhi bhi it is lagging. Abhi bhi there is lagging. Hanji, tell me in the chat box, is there still lagging? Huh? Chalo. Now you will have, if you have N and S both, then beta what will happen? If you have N and S both, then what will happen? You will react this with Fe3 positive, that is FeCl3, right? You will react this with FeCl3, it will give us FeSCN thrice, blood red precipitates. Now, if you have halogen, with this you will react this with AgNO3, acidified AgNO3, and if AgCl is formed, that is white color. If AgBr, pale yellow. If AgI, that is dark yellow. This is soluble in ammonium hydroxide. This is partially or sparingly soluble. this is insoluble. ठीक है? Okay, I have written everything that we have done in just one chart. Okay, now last is your phosphorus. Now phosphorus, what you have made H3PO3, and that reacts with this H3PO3. It will react with which thing? It will react with the Na. I am writing Na. Should I write it here? This is phosphorus. I am writing it here only. Okay? Because I don't have space, beta. I am writing it here only. Okay? With phosphorus, what you will react? You will react this with NH4 twice dot MOO4, है ना? NH4 twice MOO4, so ammonium molybdenate, and then you will have NH4. There is some gadbad here. NH4 thrice, it should be NH4 thrice PO4.12 MOO3, which is of yellow color. Okay, now everybody tell me, is this chart clear to everybody? Is this chart clear to everybody? Everything I have written here, take a screenshot of this chart. Take a screenshot of this chart. This is a very, very beautiful chart for you. If you have remembered this chart, that means qualitative analysis is done for you. Okay, you have done qualitative analysis in a very beautiful and a very colorful manner. Right? Okay, ji? Yes, everybody? Chalo. Last part is quantitative analysis. Quantitative analysis. Now, this is so even simpler. Hai na? This is so very, very simple. Quantitative analysis. Now, let us see how will we do quantitative analysis. Beta, firstly, though, we will have a formula. These all things, you don't have to do all of these things. Right? You don't have to do all of these things. Right? I will tell you a simpler method. See, first thing is you don't have to go through the theory again and again. In the theory part, they have just given us the qualitative analysis. But we want to look forward to quantitative analysis. Right? For quantitative analysis, you need to calculate the percentage of carbon, percentage of hydrogen, percentage of nitrogen, percentage of phosphorus, sulfur, halogens. All of these things you have to calculate here. Right? So, firstly, I will make one formula here. This also, you don't have to do this. Okay? I'll make one formula for you here. Okay, that is easy for you. Chalo. First thing is, I know that when I'm talking about, firstly, if organic compound has carbon, it will make carbon dioxide from that, right? If your organic compound has carbon, it will make carbon dioxide for that. You know? So, you say that if you have one molecule of carbon dioxide, that means one carbon atom is found in that organic compound. You know? If one molecule of, beta, just one derivation I will do, I will generate a general formula. From that formula, you will be able to do all the other formulas. You don't have to cram anything after that, right? So, have trust in me and tell me. You have can I say if one molecule of carbon dioxide is generated, that means there is one atom in the organic compound. If two molecules, that means two atoms in the organic compound. Three molecules, that means three atoms, right? If 1 gram of carbon dioxide is generated, can I say 1 gram of carbon is there in the organic compound, right? If 1 mole of carbon dioxide is generated, can I say there is 1 mole of carbon in the organic compound? Tell me, beta, is that true or not? Okay? Is that true or not? So, can I say here that if you have 44, what is the molar mass? 44 gram of CO2, you will have 12 gram of carbon in that. Hai na? If you have 44 gram of CO2, for example, I have carbon dioxide, then I predicted the weight of that. Hai na? It comes out to be 44 grams. In 44 grams, you have 1 carbon, and 1 carbon has a weight of 12 grams. Right? So, if you have 44 grams of carbon dioxide, that means 12 gram of carbon is there. Right? Okay. So, can I write 44, now I will apply unitary method, of carbon dioxide will give us 12 gram of organic compound. Can I say that? है ना? 1 gram of carbon dioxide will give us 12 by 44 gram of organic compound. Beta, this carbon means organic compound only, na? ठीक है? So it means 1 gram of organic, this means 12 by this gram. Now in the question, they are saying that you have W gram of carbon dioxide. Okay, this is the weight of carbon dioxide that is formed. W gram of carbon dioxide will give us 12 by 44 into W of organic amount. Beta, first you tell me this thing. Is this step clear to all of you? Is this step clear to all of you? Is this step clear to all of you? You have carbon dioxide to carbon. I know in one carbon dioxide you have one carbon. That means if I have 44 gram of carbon dioxide, that means I have one carbon. That means I have 12 gram of carbon here. Right? That means 12 gram of organic compound. Then 44 gram of carbon dioxide means 12 gram of this. है ना? Unitary method I am saying 1 gram of CO2 will have 12 by 44. And W gram, that is given to me in the question. Okay? This is given to you in the question. So W gram of carbon dioxide will have 12 by 44 multiplied by W. Okay? Now, I am writing one very important thing here. This is applicable for all the other formulas. Okay? So this is W is equals to mass of or weight of element, weight of detection compound. Beta, detection compound is not a bookish language. Okay, this is my language, you can say. This is my language, detection compound. Detection compound is these. Detection compound are these compounds that we have mentioned here. Right, these are the detection compounds. Those things which we have to test here. Right, these are the detection compounds here. Okay, okay, that we are testing here. Right, so now see this method, this is mass of detection compound. Now, this is W or M, let us take it as M. This is not W beta, let us take it as M. Okay, let us take it as M only. Let's fix this now. It's not, you can take any symbol here. I am taking M here, okay. M of carbon dioxide will have this much. Now, M is the mass of detection compound and what is W? W is the mass of organic compound. Mass of organic compound. Okay? Organic compound. Okay, beta? Organic compound. That is the mass of organic compound. Now, see one thing here. Okay? See one thing here. Whenever you need to calculate the percentage of element, how do you calculate it? The formula is mass of detection compound divided by mass of organic compound. Okay? Mass of detection compound divided by, this is the formula, by mass of organic compound. Organic compound multiplied by 100. This formula is a universal formula that you will apply for any purification, any percentage. Okay? Mass of that detection compound divided by mass of organic compound will tell us how much. For example, you have 20 chocolates. Now 5 chocolates are of Munch. Then how will you calculate the percentage of Munch chocolates? You will say mass of Munch chocolate divided by total mass of chocolates multiplied by 100. Same thing we have applied here. Mass of detection compound, that means how much carbon dioxide is released. The amount of carbon dioxide released is the amount of carbon present here, right? Divided by mass of organic compound, that is the total organic compound. For example, you have C5H10, this kind of organic compound, right? You want to calculate the mass of carbon, the percentage of carbon here. You will see total mass of organic compound over mass of detection compound. For example, you have 5 carbon dioxides here. So mass of carbon dioxide by mass of organic compound multiplied by 100 will tell us the percentage. Is that clear, beta? Now, let us see the formula here. Which formula it will become? Mass of percentage of carbon will become percentage of carbon will be, detection compound is this. This is your detection compound. This is your detection compound. But this is not a bookish language. Again, I'm saying it's just I have written detection because we are detecting it everywhere, right? So detection compound is this. This is the mass 12 by 44 multiplied by m. 12 by 44 multiplied by m. And I know what is the mass of organic compound, that is W. That is W. But you can remember this by that meme. That meme, moe, 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 moe. You remember that meme, moe, moe? So, moe, moe. I know there is no moe, moe, right? So, moe, moe, it sounds like moe. W is like oe, oe, oe. Okay? So, it is moe, moe. By moe, moe, you can remember this. Okay? M by W, M by W. And here you have mass of detection. This is mass of organic compound. This is the first formula. Now, ma'am, how this is easy, ma'am? This is so very, very difficult, ma'am. You were to saying, ma'am, you will make it easy for us, but this is not easy for us. Now, let me tell you how will I make it easy for you. Now, I am making a general formula here. General formula. This is the most important thing of today's class. Hai na? Very important. See, this formula you will not see in books because that is my language. Okay? So, if you have studied everything for me, then you will be able to understand this formula. So, see this. Percentage of element, any element that is given to you, any element that is given to you. Should I write it in the next page? Because that's a big formula. Generally what you will write, percentage of organic, percentage of element will be, from this I will generate the general. 12 by 44. 12 was the, 12, what was 12? 12 was the mass of, molar mass of carbon. That means you will, the element that you are detecting, the molar mass of that element in the detection compound. Detection compound is CO2 here. So in CO2 you have one carbon means 12 gram, right? 12 gram is the molar mass. So what you will write? In general you will write molar mass of, or you can write this with this pen, molar mass of element in detection compound, and I will tell you how to apply this formula. है ना? Molar mass of detection compound in element divided by molar mass of detection compound. Molar, we know detection compound was carbon dioxide. Okay? Molar mass of detection compound, right? Acha. Now what is M by W? M beta, any symbol you can take. Okay? So you can, if you want to write it here, then you can also write multiplied by, this will be, here you will have 100 here, right? This will be M by W. What is M beta? What is M? M was mass, not molar mass. These M and W will be given in the question. Okay? Mass of apna detection compound. Not molar mass, the mass of detection compound. That was given out in that reaction. The mass of detection compound in that reaction. Right? And here you have mass of organic compound taken. Mass of organic compound taken. Beta, if you remember these things, na, you don't have to remember any other thing. Okay? If you remember this thing, you don't have to remember anything. Take a screenshot of this. Now we will start applying this formula. You don't have to derive this again and again. Okay? You don't have to derive this again and again. Same thing will occur. Okay? You will have the same thing. Now let us see the second test. Have you taken the screenshot of this one? Beta, have you taken the screenshot? Shabash, chalo. Now we will see. It's raining outside, you know. It's raining heavily outside. So it is, second thing was, we know the second thing that we did in qualitative analysis was H2O, right? So you need to calculate the percentage of hydrogen here. The detection compound becomes H2O, right? The detection compound becomes H2O. Now, if you want to see the percentage of H2O here, right? Now beta, tell me, the formula is molar mass of element in that compound. The element, the detection compound is H2. What is the molar mass of that element? Means hydrogen in H2. The molar mass of hydrogen in H2 is 2. 1 is for 1, na? So it's not like, ma'am, molar mass of hydrogen is 1. Beta, in that compound there are 2 hydrogens present. So that is why 2 multiplied by 1, that is 1. Okay, ji? Okay. Thank you, beta. Thank you, Madhumati. Okay. So beta, here you have what is the molar mass divided by molar mass of detection compound. This compound has which mass? Firstly, the hydrogen, molar mass of hydrogen in that compound. Then what is the molar mass of this compound? That becomes 18 multiplied by mass of the detection compound that is generated in that reaction divided by molar mass divided by the mass of organic compound, and this becomes your hydrogen. This becomes your formula for detection of hydrogen. Okay, this becomes your formula for detection of hydrogen. Okay, beta. Yes, bacha. Okay, chalo. Next method is same. Next method is beta as it is same. Just the name is different. The name is Ķēries method. Now Ķēries method is caring, very caring. That is why you don't have to do anything here, right? Very caring compound, very caring method, right? Same thing beta, they are saying that, dekho, here basically they are talking about Lassaigne test only. It's just that they are talking about halogens here, right? So you don't have to answer the halogen thing here, right? So what we will do here, we will copy paste this formula and apply it here, and then we will calculate the full answer. Chalo. Now beta, just apply this for AgCl. Now tell me one thing. Whenever we are talking about AgX, what is the molar mass of AgX? In all the halogens, the detection compound is AgX. Don't say NEX is the detection compound. That is a fusion extract, right? This is the detection compound when it comes to apna halogens. AgX. X can be chlorine, bromine, iodine. Now I am making this formula more simple for you. Okay? So if you want to say percentage of halogens, the formula will become more simple here. The formula will be simple here. Which is the formula? The formula will become, beta, molar mass of element in the detection compound. The molar mass of halogen divided by, there will be one halogen, so there will be one molar mass of that halogen, divided by molar mass of detection compound. Detection compound will be Ag plus the molar mass of halogen. Beta, what is the molar mass of AgX? That is Ag plus X, right? So we know Ag is 108 and that is molar mass of halogen. Whatever halogen is, if there is chlorine, then you will add chlorine. Bromine, then you will add bromine. If iodine, then you will add iodine. You just have to remember the molar masses here. Okay? Okay? No, beta, with so much pollution, how can I see rainbow? Hai na? With so much pollution, rainbow days are so gone, I think. Chalo. Mass of detection compound that is given to us, that is M by W into 100. Okay? This becomes your general formula. This will become your general formula. Okay, beta? This will become your general formula. Now, everybody tell me in the chat box, is that clear? Okay, is that clear? Just write it here. The molar mass of Cl is 35.5. Molar mass of Br is 80. Right? Molar mass of Br is 80. And molar mass of iodine is 127. That's it. Okay, that's it. You don't have to remember 3 formulas here. Okay, I am reducing your burden here. You don't have to remember three formulas. You will forget everything. You will mix everything there in the exam. right? Just remember this thing that okay, my molar mass of element in detection compound is mx, that is my detection compound is AgX here. AgX is the detection compound here, right? That is why it will be this thing. Beta, I am writing the detection compounds in blue pen in everywhere. Okay, the detection compound here is AgX. Here it was, in this case it was water, here it was water, and here it was CO2. 5 divided by 108 plus 35.5, beta, 108 plus 35.5, 143.5 m by w into 100, right? Percentage of Br 80 by 108 point this will 127, this is m by w into 100, this is m by w into 100, है ना? Now tell me 80 plus 108, that will become 188, ठीक है? And 127 plus 108, that will become 235. Now in the book you will see these formulas, and that is why students get scared of this quantitative analysis. They are like, ma'am, how to learn these formulas? Now tell me, is this difficult? It is easy to learn now. You don't have to remember these formulas, okay? This you don't have to remember. You just have to remember this thing here, that mass of Cl is 35.5, Br is 80, this is 127, Ag it is 108. That's it. Okay. Yes, beta. Hanji, everybody in the chat box. Done, right? Now let us do the next method, that is for sulfur. Okay? This though, already, this I am erasing this, right? Because I have written it myself. Here the symbols are different, that is why I am erasing it. Okay? Now, next method is Carius method for estimation of sulfur. When you have to estimate the sulfur, then beta, what you will do? If you want to estimate sulfur here, what you will do? Acha, tell me what you will do when you want to estimate sulfur. Very simple. See, you have this compound Na2 and this. Just remember the detection compound. You don't have to remember everything. Just remember the detection compound, that according to, you will not say, ma'am, PBS, ma'am, that, beta, this is Carius method. With Carius method, it is there in your syllabus, right? Quantitative with Carius method is in your syllabus, and according to Carius method, they reacted this with Na2O2, then H2SO4, then BaCl2, and this was your detection compound that was formed. Okay? Detection compound. Again, I am saying this is not exactly any word. Detection compound is not any word in this chapter, right? This is what I am telling you so that you remember what is our focus. Okay? So now, beta, with detection compound, this also erase this one, है ना? Let's generate our own formula here. Chalo. The formula will be percentage of sulfur. Everybody in the chat box. Percentage of sulfur. The detection compound is BaSO4. है ना? Now, what is the molar mass of sulfur? What is the molar mass of sulfur? Very good. Okay? Molar mass of sulfur. I am writing it here. There will be molar mass of sulfur. This is molar mass of BaSO4. And here you have M by W. M by W. W is an organic compound, right? Multiplied by this. So this is 32 by 233, right? 32 by 233, that is the mass of BaSO4, multiplied by M by W into 100. Okay? You don't want to remember this 233, you just remember the molar masses, right? Then just calculate the BaSO4 mass, right? Okay? Array, no issues, beta, no issues. You just focus on one thing, that is like, share, है ना, and do comment down, है ना, do comment, है ना. It doesn't hurt me. To a teacher, it never hurts when they have to stand for hours and hours to teach. To a teacher, what hurts is when they are not appreciated, है ना, when the students don't appreciate that thing, right? So this is your percentage of sulfur, right? Next is for the detection of, acha, this so we have done, this is for phosphorus, not for sulfur. Right, this is for phosphorus, this is not for sulfur. This is for phosphorus. Acha, tell me, beta, in phosphorus, When you detected it, what was the compound? What was the final compound that was formed? Tell me beta, what was the final compound? Hanji. What was the final compound? Here this will become the detection compound, okay? Here this will become the detection. Just remember the detection compounds here. This is your detection compound. You don't have to remember the form, this full reaction again and again. Just remember the detection compound. This is all Quete's method, okay? So this is your detection compound. Same formula will be applied. Now beta, the formula that is applied here is, okay, see one thing here. Why I'm writing it again? Because, acha, tell me one thing. Abhi light has also gone, so we need to finish it, right? Chalo. Now beta, see one thing. See one thing here. Your percentage, right? Your percentage of phosphorus will be, that is going to be, what is your mass of phosphorus? That is 2 into mass of phosphorus. Phosphorus is 31. So 31 into 2. 31 into 2, that will become 62. Divided by the full mass of this compound. The molar mass will be 222. Right? And this will be m by w multiplied by 100. That will become your formula here. Right? Okay. Thank you, beta. Thank you, Madhumati. Thank you so much. Okay. Now this is one more. This also we have done in qualitative, quantitative analysis. है ना? Qualitative analysis, we have done this reaction. Right? This is your detection compound. This is your detection compound. Right? And here we know that the phosphorus, you have just one phosphorus here. Okay? That is why this is 31 divided by 1877 is the molar mass of this thing. Is the molar mass of this compound. Multiplied by m by w into 100. So this becomes your formula. Okay? Chalo. Now, very important, two important formulas, that is Dumas and J-Dal's, right? That will be our last topic of today and this chapter will be finished, right? Now you have J-Dal's, okay? It is 2222, 622, wait a minute, let me see, let me calculate that, mgp207, it should be more than that, let me calculate that. Let me calculate that, wait a minute. Just give me a minute, let me verify. mg2p207. Beta, it is 222 only. It is 222 only, Rathi. It is 222 only. Okay? Correct that. Okay? Chalo. Now, next is your Dumas method. है ना? Dumas method. So, Dumas method is a different method. The formula is completely different. How this formula was generated, everything is not in your syllabus. You don't have to get into that. Just understand how to apply this method. Applying this method is very important for you. Okay? So, you have P1 minus P minus. We know that in ideal gas equation, we have a thing that is P1 V1 by T1 equals to P2 V2 by T2. Right? With this P1, you have just this extra P here. That extra P is the aqueous tension. Now, beta, everything, we will also do numerical on this. Okay? This P is your aqueous tension. This is your, P1 is your aqueous tension, right? And P is your pressure of moist air. This is very important. Now, all these terms will be given in the question. Whatever is given in the question is 111. What is not given in the question is the standard. You just have to understand that thing. How to apply this formula is a task. Okay? Thank you, beta. Thank you, Sharan. Thank you so much. Thank you, beta. So sweet. And I'm sure that this is going to help all of you a lot because, you know, these things are very important for your preparation at a time. Like, it's not like You have to start preparing 2 months before, right? So this is P minus P1, that will be given to, whatever is given to in the question will be 111. What is not given in the question will be standard, right? So your standard thing is, you will take standard P2 as 720 or 23. Wait a minute, let me see. It was 715, I guess. 760. So sorry. That was 760 mm of Hg. Okay, that is your standard pressure, mm of Hg. Because the question will be given in mm of Hg only, right? Then beta, your V2 you will calculate, and temperature will be 273 Kelvin. This will be your standard temperature, and from here you will calculate the value of V2 in milliliters. This V1 will be given in milliliters. You will calculate the value of V2 in milliliters. Okay, beta? Understood this? Yes, everybody in the chat box understood this? You will calculate the value of V2 in milliliters. Now, beta, after that, what you will do with this V2? Now, we all that number of moles is equals to given mass, that is mass of N2, by molar mass. What is the molar mass of N2? 28. Okay, 28 is the molar mass of N2. Achha, what about this? Number of moles is also equal to given volume by molar volume. Given volume is this volume that we have calculated here, right? So this is your V2, and your molar volume in milliliter is 22400. Okay? In that is 22400. Hai na beta? Okay? Okay, Baswa sir is also here. Chalo. Okay, beta, understood this thing. Now, what we did here, this is Dumas method. In this, you have two things. One pressure, volume, temperature will be given to you. That is your 111. Aqueous tension will be given to you. That is your aqueous tension. That we will mention that, right? That is the aqueous tension, right? Then this is your standard thing. P2, T2, that is fixed. They will not give you in the question. V2 you will find out from here in the milliliter, right? Convert this into milliliter as well. If they give you this V1 in liters, convert that into milliliters. Don't, create a mess out of it. Just fix one unit here, right? After that, you fill that. This is in milliliters. If you fill that in milliliter, you will put 22400. Okay? Now, M2 will become mass of, this will become multiplied by 24. This will become 28. Now, what is the percentage? Now, I told you in the first formula sheet that percentage is, where it is, percentage of element is mass of detection by mass of organic multiplied by 100. Acha, organic compound, tell me, organic compound is always W. Okay? Organic compound is always W. So that will be W. Acha, mass of detection compound, N2 is the detection compound. Here mass we have calculated, that will be V2 ml in milliliter 22400 multiplied by 28, and mass of organic compound is W multiplied by 100. Okay? This will be given to you. This you will calculate. In the end, you just have to remember this thing. Remember this formula. Remember this formula. Mark it DM. Okay? Remember this formula. V2 calculate it by using this particular equation. Okay, ji? Okay, ji? Chalo. Don't worry, Cap2 will also come in few minutes. Okay, chalo. Understood this? Yes? Yes, beta? Shabash, everybody in the chat box. Hai na? Clear? This is Dumas method. Now, jail dals is very, very simple. Jail dal is like jail only. Now, what kind of jail? Don't remember this one. Hai na? Chalo. Jail dal method is so even more easy. You don't have to remember this reaction, nothing. Just remember this. Why it is at such a large distance? Why it is at such a large distance? It's like, I don't want to talk to you. Okay? So this is N into V. So what is N here? N is normality. N is normality. Okay? V is the volume. We know that normality is equals to N factor into molarity. So in the question, they might give you molarity and then you have to calculate normality. and then just put the value. N will be given, this will be given, W will be given, percentage of N you will calculate, right? Okay, here also instead of writing N2, write N only. Okay, percentage of N. Okay, ji? Right, beta? Understood this thing? Everybody in the chat box. Okay, ji? Chalo. Now, let us do some question. We have completed. Acha, one very, very important theoretical question is there, that in which compounds J-Dal method will not be applied. So, first is containing nitrogen of nitro and azo group. If you have nitrogen of azo group, that is N2 azo group, or nitro group, NO2 group, that will not be detected by the J-Dal method. That is the limitation. Second is nitrogen present in the ring. For example, pyridine, pyrrole. In all these rings, the nitrogen present here. And in pyridine, the nitrogen is present like this. So this is in the ring. This is heterocyclic ring. So in that, this nitrogen will not be detected because that is in the ring. Okay? Chalo. Nitrogen of these compounds does not change to ammonium sulfate under these conditions. Okay, ji, chalo. Now, this was the chart of your formulas, right? That with CO2, you have 12 by 44, with H2O, 2 by 18. AgCl, these are the detection compounds. Okay, write it here. These are the detection, beta. To qualitative, quantitative analysis, I have already made a chart for you. Qualitative also. This is quantitative. Take a screenshot of this. Take a screenshot fast, everything. Acha. Next is sulfur, phosphorus. These are the detection compound. Dumas method, right? J-Dal's method. This is the formula, right? Okay. Hanji. Now let us do some questions. Fast, let us do some questions, right? Let us do the questions. NEET 2020, the question is paper chromatography. Paper chromatography is an example of adsorption chromatography, partition. Now be active in the chat box, okay? Now I have taught everything. Now it's your turn. Students will run now. They will be like, ma'am, we have understood, but we don't want to do PYQs. Why? Because, ma'am, we don't want to be topper. We just want to give, it's like telling yourself blindly that you have studied, but when you have not practiced, that means you have not studied, right? You don't know how to apply that in the question, that how can you say you have studied, right? Chalo. Now, paper chromatography is an example of which chromatography? B. Very good. Partition chromatography, NEET 2020 question. A very, very, very simple question. 1 second question it was. And students just leave this chapter like that, right? You have no idea how simple questions they ask from this chapter. Next question is, the most suitable method for separation of 1:1 mixture of ortho-para nitrophenol. Acha, everybody in the chat box, I know. B for Baswa sir. Bilkul, bilkul, bilkul. Acha, everybody in the chat box, the best method, ortho and para. Ortho is steam volatile. Para is not steam volatile. So we will say steam distillation. C is the best method here. That is NEET 2017, 1999, 1993. Same time the simple question has been asked, right? Because that is the line of your NCERT, that is why, right? Next question is the best method for separation of naphthalene and benzoic acid from their mixture. Again, a very simple question. From naphthalene. Naphthalene is a sublimable substance. And benzoic acid is a non-sublimable substance. So what you can do? You can apply the method of sublimation, that is B will be your correct answer, right? Next is this one, that nitrogen detection is an organic compound is carried out by Lassaigne test, or Lassaigne is a different pronunciation for this, right? This is NEET 2013 question, but I told you now their focus is more on qualitative and quantitative analysis, right? So nitrogen, everybody, I can't believe you guys here. I can't believe you guys. You have no interest in doing the PYQs. Like literally no interest in doing PYQs. Seriously. Nitrogen detection is an organic compound is carried out by Lassaigne test. The blue color formed compound. Blue color is Prussian blue color. And that compound is what? Everybody in the chat box, Prussian blue color. That compound is Fe3, Fe4, FeCN6 twice. Right? So that is, Fe4, FeCN6 thrice. Sorry. So this is your Prussian blue compound. Right? Just the coordination compound you have to remember. Next is this Lassaigne extract is boiled with concentrated HNO3 while testing for halogens. By doing so, now this is your AIPMT 2011 question. Here what they are saying that you have Lassaigne extract that is boiled with concentrated HNO3. Why we do that? So that to decompose Na2S and NaCl formed. Right? We want to decompose the things that are formed. Right? Okay, that is why because beta dekho, if you have this halogen, when you are testing for halogen, then in that case you have to decompose this Na2S and NaCN also. That is why we heat it with the HNO3. Okay? So this NaCN will be reacted with this and it will decompose, and Na2S will also decompose. Right? Okay. Next question is, in sodium fusion test the organic compounds, the nitrogen of the organic compound is converted into which part? Now, in sodium fusion, the nitrogen of the organic. Now, beta, whenever you will have nitrogen, always you will have sodium, carbon also. So, it is NaCl. Okay? Sodium cyanide. So, answer will be B, that is sodium cyanide. This is a very old question. Right? Next is, chalo. Now, this is going to be our last question, right? One question I will give you for homework, right? So, in Dumas method for estimation of nitrogen, you have estimation of nitrogen here, right? You have this one, beta, this is the mass of organic compound. Now, I told you that mass of organic compound will be taken as W, right? That is why I have specified those things for you, right? So, this mass, this is your 2015 question. Okay? And if this from Dumas and Gilles, they ask you questions, especially from Dumas, right? That means they have not asked you a very simple question, right? Because so many students, they don't know how to apply this method. And they just cram the formulas, but how to apply, how to solve the question, they have no idea about it, right? So this full big paragraph will be given. From there, you have to identify which is P1, which is P2. So in Dumas method for estimation of nitrogen, this is your W. Okay? W of an organic compound give 40 milliliter of nitrogen. I told you the volume that is given will be your V1, right? So this is your V1 that is given of the nitrogen collected at 300 temperature. So the temperature that is given is T1 and this much of pressure, and the pressure that is given is P1. Okay? Aqueous tension is given. Aqueous tension will be P. Okay? And the percentage of nitrogen they are asking. So, beta, very simple thing. Firstly, to do P minus P1 by V1. P minus P1 multiplied by, let us do in the next page only. P minus P1, everybody in the chat box, shabash. P minus P1 V1 by T1 equals to P2 V2 by T2. I told you one thing, that T2 is fixed here. T2 is standard, that is 273. P2 is also fixed, that is 360. And V2 you have to calculate from here. T1 here is 300 Kelvin. So we will write it 300 Kelvin. P minus P1. P minus P1. What is P minus P1? So we know that P is, it's not P minus P1, it is P1 minus P. Okay, so P1 minus P, this is your 725 minus, basically you have to minus this pressure with this one. So it is 725 minus 25, that comes out to be 700 here, right? 700, and this is volume is given to be 40 milliliters. 40 milliliters. Now just solve this one. solve this, you will have your volume. Let me see. Beta calculation तो you do yourself only. ठीक है? Let me see. V2, beta don't look at this one. ठीक है? You will get confused. है ना? Just okay. V2 is coming out to be 33.52. Beta do the calculation yourself. So it will be 33.52. Okay? This will come out to be 33.52 milliliters. Now, I told you when you have calculated V2, then just apply the formula that percentage of N will be equals to which thing. What was the formula here? This formula I told you, na? Where is that formula? (28) by volume, V2 by W into 100. Okay? This was the formula. We have also calculated the formula here, right? This is your V2, right? Or you can say V2 by 22400 28 by W into 100, right? Chalo, let us apply that formula here. Chalo, percentage of nitrogen will be 28 by 22400. This is your V2. V2 is 33.5 divided by W. W what they have given us, that is 0.25 multiplied by 100. Now solve this, you will get your answer. Okay? Solve. Yes, beta, that is coming out to be 35.5, is it? Here they have calculated it as 32.5. 33.5 they have calculated it. Okay, so check that. Okay? So here it will come out to be 16.76. Okay? 16.76%. Okay? Understood? How you did that? Beta, the difficult part is not the calculation. The difficult part is to understand which is P1, which is T1. Right? In Dumas method for estimation of nitrogen, when this much of organic compound, that means it is W. Volume that is given is V1. Temperature that is given is T1, and the pressure that is given minus aqueous tension will be your P1 here, right? And then you will just apply this formula here, hai na? That is P minus P1. Here you will minus the pressure that is given will be subtracted, aqueous tension will be subtracted from that, and hence this is V1, this is T1, this is calculate V2 from here, put that V2 in this one, and you will get your answer. Basically, this is 28 by 22400 V2 by W into 100. Okay? Okay, ji? Chalo. Simple na? Now we will see one more question exactly like this. Acha, this is the Ghale-Dahl method. Ghale-Dahl method asked in 2014. You can easily see these kind of question in your NEET exam, right? So in the Ghale-Dahl method for the estimation of nitrogen, this is very simple. Is present in a soil sample, ammonia evolved from this sample. Acha dekho. Ammonia evolved from 0.75 gram of sample. Sample means organic compound. That means W is given to be 0.75 gram. Okay? Neutralized to 10 ml. 10 ml means volume is given to be 10 milliliter. Molarity is given to be 1. If molarity is 1, N factor for H2SO4 beta. For H2SO4 it releases 2 H positive. So N factor, we have done that in some basic concepts of chemistry. N factor is 2. So normality will be 1 into 2, that is 2. Okay, 2 normal. Now what was the formula? What was the formula? Everybody in the chat box, what was the formula here? What was the formula? The formula percentage of nitrogen equals to 1.4 by W into normality into volume. So it will be 1.4, W is what? 0.75 multiplied by normality is 2. Volume we have, where is volume? That is 10. Okay? So this will become your percentage of nitrogen. Okay? Simple na? Simple question. Batao. Everybody in the chat box. Is that clear to everybody in the chat box? Yes. Simple question, beta. You just have to apply the formula. Sometimes they will give you the normality directly. Sometimes they have given you molarity, है ना? After molarity, it's just that you don't, it's not like you just cram the formula. You also have to identify which term is given to you, है ना? That will happen only if you have read this question somewhere, if you have done the practice, okay? And if you ask me, ma'am, do I need to do more practice of this chapter? No. This is enough. This is enough. Just read out the NCERT back exercise question. PYQs, so beta, these are the only PYQs it has, right? So it is not frequently asked that it will have like tons of PYQs. You will have just maybe 10, 15 PYQs, more 10, 15 PYQs you will see. It will hardly take you half an hour to do the PYQs, right? And then see the back exercise questions and then go through the NCERT. Okay, go through the NCERT ones, right? Otherwise, so I have covered. If you even if you don't want to do NCERT, that is also fine, okay? Because I have already covered it. Acha, beta, this tell me NEET 2014. Again, they have asked you this question regarding Dumas method. In 2014 and 15, they were very into this Dumas and 𝐤𝐤 method. This is the last question of today. Last question of today. Acha. See, I'll just tell you that what to do here. Okay, you will solve it yourself and give me the answer in the chat box. Okay, so I am deleting the answer slide. So I'm deleting the answer slides here, right? I will give you the answer slides in the next page or in the next class, or I will give you the answer slides on my Telegram channel. But I will surely tell you that which is P1, which is T1, but you have to give me the answer, the percentage in the chat box. Not in the chat box, in the comment section. I will wait for your answer, right? This is the most predictable question of this chapter, Dumas method, right? Okay, if you're able to do this, that means yes, nobody can beat you. Acha, in Dumas method, the estimation of nitrogen, right? Let us firstly see which is P1, P2 and all of that. Estimation of nitrogen of this gram of an organic compound, this is your W, this is W, gave 55 milliliter of nitrogen, this is your V1, this will be V1, right? Collected at 300 Kelvin, that is your T1, and this is your pressure, okay? And this is your P1, atmospheric, this is aqueous tension, right? The percentage of composition of nitrogen in the compound would be, right? So I'll give you two formulas here. I'll just write two formulas. P minus P1 multiplied by V1 by T1 equals to P2 V2 T2, right? And then percentage of nitrogen will be 28 by 22400, and this volume should be in milliliter. V2 should be in milliliter, right? And then this is your weight that is given to you for organic compound into 100. Apply these two formulas and I will wait for your answers in the comment section. I will wait for your answers in the comment section. Take a screenshot of this one. Everybody, take a screenshot of this one. I will wait for these 12 kids that are watching this now. I am waiting for your answers in the comment section, okay? With this much hard work, if you're not, not even doing your homework, then I mean, what is the use here? What is the use? And then there is no use. You are fooling yourself also, right? So I really appreciate those kids who actually not only appreciate me for this much hard work, also do their homework, right? Okay, also do your homework. Okay, bacha? So I'll wait for your homework. Take a screenshot of this one and tell me which will the correct answer. So you have already seen, right? Okay, but try to solve it yourself. Okay, ji? Chalo. Now, before going, everybody, that's a reminder for all of you to get enrolled into the, because in the starting of the October, this test we will take this test, that is scholarship test, where you are going to get amazing rewards like iPads, iPhones, drones, and beta, not only that, you will get also free, totally free of cost, the Vedantu courses and as well as the study material. Now, ma'am, what's there in the study material? You have your video solution, test series, mock test, you have PYQs, NCERT solutions, CBSE question solutions, NEET solutions, everything, paper, now state-wise I'm saying, year-wise and chapter-wise also. Moreover, you have an amazing thing, that is your doubt app. You will get access to Vedantu doubt app, right? So Vedantu doubt app, you can ask 24/7. You can ask any teacher your doubt. Now that is the best part, right? So do get enrolled to this. The link is in the description because that test is going to happen within 10 days and all the details will be given to you in that link itself. Okay, ji? Chalo. Okay then, beta. Bye bye. Take care. See you all in the next class. Till then, keep smiling and keep spreading love around you and keep studying also. And you can always talk to me on Diksha Kaushal Chemistry Official and also Vedantu NEET English. Okay, then beta, don't forget to like the session. Don't forget to share this session on your WhatsApp group. If you have, if you have felt that, okay, ma'am has done hard work here for us and you really feel that this lecture should go to other students also, other students should also watch this lecture, don't be so self-centered, okay? So then share this on your WhatsApp, right? And also comment down and also do your homework. Bye bye, beta. Take care. See you all.